All right, good morning, everyone. Welcome back. Congratulations. You have made it to the final day of our masterclass. Scanning and then reviewing some aspects of how the network attacker can try and exploit vulnerable systems. Just before we get started, I would like to make sure a few things. One, how's my microphone? Are you able to hear me okay? All right, thank you, Sindri. Thanks very much. And two, sharing the slides. Can you see the slides that we're sharing at the moment? All right, great. Okay, well let's go ahead and get started. Now, yesterday we went through additional scans. We also used some network scanning tools to include ZAP. We also used a couple of OAuth tools. We used Directory Buster, and we tried to see all the different areas, okay, for where initial vulnerabilities may exist. We went into Nmap scanning engine. We looked through every single line because every line takes time to know, is this what we need? What is there? What is useful to help stage and guide our attack? All right, and then we are going to finish up on one of the tools, Skipfish. And then from Skipfish, we'll move into additional vulnerability scanning and vulnerability sessions for today. Now, questions. Are there any questions from our first day or second day? Any lingering questions out there? All right, well, I am not seeing any questions, so I'll take that as a no. Okay, so to finish up from where we were, let me advance us to, it's not that way. Okay, so this is where we stopped off. We finished on ZAP. We saw the different areas. One of the things we want to focus on with the OAuth ZAP tool were the alerts. In case, as we're scanning at the bottom side of the screen, let me see if I have. So whenever we're doing the scan at this bottom side here, if we can click on the alert, and then from the alert, we can view some of the aspects that this OAuth ZAP tool has identified. In particular, we care to see if, what are the most malicious alerts out there, like directory listing. Can it determine that directory listing is there, that there's a problem? Okay, and if so, what can we learn from the different entries that are out there? All right, so let's go to Skipfish. So Skipfish is a tool, is an active web application and security reconnaissance tool. It prepares an interactive sitemap for the targeted site by carrying out recursive crawls and directory-based probes. Then the resulting map is then annotated onto a screen with different output that allows us to have interactions with it. We can see different uh, um, we can see different alerts, different vulnerabilities, and it also gives us a scale of severity. Some things are more critical than others. Some are just fine in warning. But let's go ahead and run with this tool, and we'll see what we get. Okay, so on my screen here, let me bring up my VirtualBox. Here I am. I think I have my other VirtualBox machine still running, so I'm gonna close this guy just to make sure it's off and refreshed. And my DVWA, let's go ahead and close that one too. All right, with both of those machines off, let's go ahead and restore our snapshots just as before. Snapshots, restore. And this one, since we're pros at it, let's go there, restore. Restore. Let's get that one started. All right, that one's coming up. Let's get that exploitable started as well. And now we'll just wait a second for our systems here. And let's get the DVWA started also. Okay, that one's starting and it is up. Wait, there is something wrong with this one. All right. Let me go ahead and close this. Let me start this one again. It's not updated, restore. Let me restart again. All right. Okay, with our two systems up and running, let's go ahead and ping both of them to make sure we still have connectivity to our systems. Okay, I'm going to do a ping to 169.254.8.81. It's our Metasploitable box. We can reach it. Let's also do the same thing for H3. That's our DBWA machine. So that's good. I'm very happy with that. Okay. There you go. All right, so on our desktop machine, in fact, I'm going to save this into the share. And so just a reminder to everybody, the scans, all the scans that we were doing today that we have completed, they're in the Google Share Drive and they've been updated. So you have everything for today and the other 2 days of our workshop. Let me add in my share again. And this one we've done many times. So I'm just clicking. I don't know, it's not coming up. All right. Good. Close here. Open terminal. All right, so this is where we are. So now I have my terminal ready. I'm going to store everything out in my share drive so we can keep an archive of that, and use it, also access it from our host machine easily. I like to do that via the share. Okay, so let's go ahead and enter in the commands. The commands, I'm about to drop it in the chat for you. All right, we are. It's in the chat. Skipfish -O for output. Now I want to save it in the same directory that we're currently running from. So skipfish _ DVWA, because we'll do this for a DVWA machine. And HTTP, and then the IP address of our DVWA machine, 254.8.83. And it gives us this message, hey, welcome, about to get started. And we'll say, okay, no problem. Now we'll wait a little bit for it to complete its scan. And the scan, might take a minute or two. The scan doesn't take too long. And what it's doing, it is crawling the websites. It's crawling every site that it can find, looks at some of the responses from the web pages, and then tells us what is vulnerable and what is not vulnerable. And right after this one, I'm also going to have us pivot into establishing Nessus. So we're going to bring Nessus up next. We'll get Nessus to scan both the DVWA as well as the Metasploitable 3 machine, and we'll focus our efforts on the Metasploitable 3, because that's what we'll do our attacks against later on today. It shouldn't be too much longer. Has anyone else's finished yet? Okay, okay, good, good, good. Good responses. Mine should not be too much. I shouldn't be too far behind you all. Writing the crawl tree. $14.97. Okay. Very nice. I do like this quote at the end. Okay, let's see. Let us now go and analyze what we have scanned. So here we are in the skipfish directory, skipfish DVWA. Now this main directory here has all of the files and images and things to show up in a web page. So we are looking for index.html. Right here. Okay, so in our skipfish DVWA, we're looking for index.html. As soon as we see this, let's go ahead and open it. Okay. All right, excellent. So our scans was successful. And if we just quickly view the information that it presents us, here's some of the document view that we can expand each of these to determine what that website looked like. We can see at the top here kind of your initial dashboard, small type of dashboard. It says one for your most critical. We can hover our mouse over it and it says that there's one high risk, two medium risk, 38 notes, and then 80 type of items that it's going to have here stored in different places in the unit tree. Right? If I expand this, I can see some of the header information that was exchanged between our system and the victim that we are scanning. Now, since we're doing scans, I kind of like to jump to the most critical first, because that's possibly my easier entry mechanism into the system. So let's go ahead and do that. Here I'm going to look at query injection vector. So here it's saying that, there is an injection vector possible for that login.php. If I click on it, I can see that, okay, the injection is via a form. So in fact, we executed this type of injection yesterday when we were using the nmap HTTP form brutes. It was like the brute form scan, in which it looks for entries, like a username and password type of entry or forms on a web page. And then if it can automatically find those, it will try and enumerate through its word list of usernames and passwords. So you're trying to enumerate through the username and passwords, it will see, hey, can I gain access to a system? And if so, it will report back that it was able to gain access to the network using whichever website, whichever credential, username and password. That's what skipfish is identifying here. And then if we click on show trace, it can take us to the specific network sections, like kind of the network headers that were exchanged during the analysis, which is really cool that you can immediately pivot from the web page into the trace, the trace of the communications. And then see ending of form, Here's the username and password. So we do not have time to get into that in this session, but a very, very, very good tool. In fact, it is a tool that we utilize in the 201 from this current master class. The second one that gives us more hands-on, more advanced of the scanning and exploitation, we actually utilize automatic brute force scanners to use different techniques to gain access to systems like this. So it's really nice to do that, but that's in a separate class. It's not hard to find. You know, this Google Hydra is the tool that we could use. I'll put it down here in the chat. Hydra, and you can actually use that, a tool similar to that, to give you brute force access into a website here. Okay, Pal, I'm reading your message here. When I do the Nmap script HTTP scan, okay, against DBWA yesterday, the script, yeah, found no valid account, but when I ran the single script, yeah, form brute today, yeah, it found. So that's one of the things. I can't say it's bad luck, because it did the same. It does the same thing to me also. I don't know if there are different parameters whenever we're using the categories that might be passed in to that specific script. And from the categories, that's different than when we execute it ourselves. That one I don't know. You know, what I would say is, as we go through the categories and the types of scans, as the attackers, we do find what we like. Find what you like, find what responds appropriate to you, and then I add those scans specifically against the target system. And this also allows me to specify different arguments / parameters as needed. So it's not just the basic, you know, initial domain or IP address that's being used for all of the scans. So it's a great question. I'm not exactly sure why, but you know, it could be an argument, but yeah, at least that's the way I do it. You know, we see what we like and then execute it one by one. Great question. Yeah, Benji, it could be packet loss. You know, that's another thing. It could be. I would not attribute a, you know, 1 or 2 packet losses for the whole thing to be lost. You know, maybe a port to be missed, possibly. But as we try that, because when you do the brute force, it's brute forcing like thousands of entries. You know, thousands of username and password that's in its list. So I don't think it's that. It's most likely an argument that's just different from the categories or something. or RK, or maybe the VM is running hot. That's that's possible. Nice. Yeah. But you know, it's an artifact, and we'll call it a known feature. All right, great question. Yeah, so I press escape, I can get out of there. Now I can look at other messages that are exchanged that this skipfish tool has been able to provide for us. If I go to the top, it says that there was a JavaScript page here. You know, again, we can show the trace. We can also decide to visit this or to download this file, just different files it was able to find. The HTML, so this is also part of our directory, like our directory traversal that it found based on links. It crawled all the way to determine that, hey, there are HTML / XML documents or files at these location spots. Another website, you do the exact same thing and you just see what all you are able to uncover. Images, different images that it found. So GIF images all throughout the website and it's crawling. Those are here. Without loss of generality, PNGs are identified. Text CSS files, help login name. Sometimes you might find secret files that, you know, again, the admin did not mean to leave out there, but it was detectable. So again, we analyze these line by line to see what is useful, and then we store that to use in our attack / exploitation / reconnaissance. Okay, and then the text, where there was text information, text HTML, it discovered that here. Interesting server messages were found. Messages from the PHP. You know, we can extend the trace to see what messages came back for us. Incorrect or missing character set, less useful to me. Password entry. So I like this, where it says password entry form, consider brute force. So that's good. It's good when these can help guide us towards a potential attack entry or attack vector. It's always best if you can masquerade as a legitimate user, especially if you can find what user names are there. Utilize those. That may be a separate mechanism inside the system versus spending the time to write a brand new exploit, because that takes time and is very costly. And then another thing I remember yesterday, I was like, I really, really like directory traversal. I love seeing that there are some directories that are out there that we can find. This one said, hey, here are hidden files / hidden directories that it was able to uncover. This one is saying access forbidden, this about. So, okay, this log, it just brings us back to the login page. Okay, then look at this one again. So these, Skipfish has identified a very good website scanning tool that directory listing is enabled. Directory listing is enabled. So if we can, we'll probably get that. Oh yeah, this is the index of. Remember when we were saying like index of is so wonderful. I love index of. Look at these index ofs once again. So it's different tools that provide some information similar, some information is just different. It depends how it is interpreting in the word list that it is using versus another tool to let us know that, hey, here's what's useful. And then we add all of these lists together, we aggregate the information, and then we can use it towards our attack or our penetration test. Then all these stem from the DBWA, icons, directory listing. Lovely, index of. Those two, and then other messages here at the bottom. Right, so that's just another tool that is very useful to us in the analysis of systems. Let's do Metasploitable 3. Let's have Skipfish run against Metasploitable 3 and see what it can uncover. And while that's just running in the background, let's move to getting Nessus up and running, because Nessus is going to take a little bit of time to scan. So while we're going through a few other aspects that we have in our workshop here, Nessus will be finishing for us. So as soon as we're ready to get to Nessus, it's there for us. So let me pause. Okay, so here we are. I'm just going to press up on our keyboard. And then instead of DVWA, I'm going to say Metasploitable 3. Metasploitable 3. And Metasploitable 3 is on 81, I'm sorry. 169.254.8.81. So we'll launch that and we'll hit go. That was really, really fast. I feel it probably did not see the full ports that we need. That's all right. That's all right. That's all right. Yeah, that's right. Okay, let's get Nessus up and running. So I have a few things for you on our Nessus. And that is right here. Okay, so again, we're moving towards this because it takes some time. So I'd like to get this running. We'll do a few other things and then we'll come back to this. Right. So Nessus proprietary. Proprietary, it costs money. The enterprise version of Nessus costs money, a lot of money. Nessus is an expensive tool, but it's constantly updated. It is well updated. It is well known, well utilized in professional industry. And you can use this to perform vulnerability scanning / vulnerability assessments against your systems. One machine, multiple machines, your entire network, you can use Nessus against. Nessus Scanner covers a wide range of technologies, including operating systems that it can scan, network devices, hypervisors, databases, web servers, and critical infrastructure. So it also means it doesn't just scan computers. Works with computers, has scans for iPhones, embedded devices, your SCADA systems. It can also do initial scans to provide some sort of assessments based on what is populated in its database. Then the results can be exported in various formats. And in our slides, we export them in all three formats. It has an HTML format, a PDF format, plain text, and the plain text is like a CSV. Those are the three main ones that we care about in our format. The LaTeX is not available in the community version that we are using. Then the results can be saved in a knowledge database for debugging. On Unix, the scanning can be automated through the use of command line agents. There also exists many commercial and other types of free open source tools to help us. One tool that we did not go into, which is really, really nice, it's just not that, it's not that good looking, if I'm honest. But to be fair, it's a great, great tool. That one I'll put in the chat here. It's called OpenVAS. So with OpenVAS, you can YouTube, Google how to set it up. The setup is really easy, is very simple. You can apt-get and setting up most of it, and then you can follow along for a few more setting up instructions. But with OpenVAS, it scans very, very, very similar to Nessus. Some of these tools are pretty about the same amount of information. Just Nessus, since it costs money, a good amount of money, it's pretty. Nessus is prettier in its analysis. OpenVAS, it's open source, free to the community. It doesn't look as good, but the information is still valid, and it all depends on what you're comfortable with. If your enterprise, your systems, your people, who control the checkbooks, if Nessus, the enterprise version of Nessus, is not tenable in the immediate future, then you can still amalgamate the information that you require from OpenVAS, a tool like OpenVAS, and then our Nessus scans, and you can pretty much get about the same information from both of those. Then also it provides additional functionality. So this is just what I was mentioning beyond just Windows. It also does stuff for SCADA, PCI compliance, different types of audits. So it's a good tool. All right, so what we're going to do is let us set up Nessus scans on our machine. So the first thing to do is to run a few commands. I will put that in our chat. And that's done. We have the address as well. All right, so let's get Nessus started and running properly. And to do that, let's do sudo etc initd nessusd start. Initd nessusd start. We'll enter the password, which is Kali again, Kali. And then hopefully we have a message similar to this that says Nessus service is already running. And if you're having an issue with this, please give me an alert in the chat, and we'll respond to it. Then let's start the service. Let's check the service's status. NessusD status. So this status I don't like because it says active, inactive, or dead, from previously starting it, and that's okay. Let's restart the service, and then we'll check the status one more time. Let's use up. So sudo service nessusd restart. Sudo service nessusd restart. And now when that restarts, let's check the status once more. And we should have something just like this now. And this is what we are more comfortable with, knowing that, yep, Nessus is up and running, all good to go. We're just about ready to begin our scans. All right, now let's navigate there. Opening Firefox. On Firefox, if I go to HTTPS, Kali, your local host, 8834, this should bring us to our Nessus client, the Nessus web interface login. And on your virtual machines, I configure these for you, and I save the password. The password is in the slides. It's just root_hacker, the username, and then the password is root backwards, TOOR. Just in case, but everyone should be here. It should be saved for you. And I'll say, remember me again, why not? And then let's go ahead and sign in. So now with Nessus running, we are signed in. Hopefully everyone has the base image here, here, where it says my scans, and then we're ready to scan. Is anyone having an issue with that? Okay, all right, that's good. I'm not seeing any problems. Perfect. All right, in that case, let's go ahead and do 2 new scans. We're going to do a scan for DVWA and then a scan for our Metasploitable here. So to do that, please click on New Scan. At the top right here, click on New Scan. View Scan. And from the previous page, you clicked on New Scan just right above here at the top right side. And then if you click on Basic Network Scan. So New Scan up here, and then Basic Network Scan at this side. This is the best working feature in this free version of Nessus. When you have the commercial version, you have even more options that appear, and it's as I said, it is a sweet tool to use. So we click on the new basic scan at the bottom. It's like new basic scan. Let's go ahead and enter in some scan information. So if I want to scan DVWA first, I'm just going to put in DVWA here, DVWA. And then in the description, we'll say it again, DVWA. That's fine. You can be more verbose if you desire. I'll just DVWA, DVWA. It'll do what we need it to do for its sake. And then the target list that we are going to scan, you can actually have it scan multiple targets. You can give it like a CSV, similar, comma separated values of IP addresses. But for us, I just wanted to scan one, and then I'll click on it, and then I'll click off, and then there'll be the Metasploitable 3 to scan. So I'm going to give it one IP address at a time. So our DVWA IP is 169.254.8.83. So I'm just going to verify what we have again. DVWA scans added to my folder, not an issue. The IP address 169.254.8.83. Always check that again, and then save. So we enter in all this information, and then we hit save. Hit save. It's saved, and now that's saved appropriately. We should have DVWA listed here, schedule on demand, and nothing is running. Excuse me. And nothing is running it. Let's configure another scan right here. So we'll say new scan once more. Top right, new scan. We'll come over here to basic network scan again. Basic network scan. In our basic network scan, this one we will set to be Metasploitable 3. Metasploitable 3. We'll use that for both the name and the description. And then the IP address is the IP address of our Metasploitable machine, 169.254.8.81. Once we've entered it in, we do one more sweep to make sure the information is correct. Metasploitable 3, 169.254.8.81. We'll hit save. Okay. Now we have 2 systems here ready for scan. To initiate the scan, if you move over here to the right side, did you see where it says launch? So here I'm going to press launch on both of these. Launch, and then you see the running symbol. So it's running. It tells that, hey, Nessus is performing its vulnerability scan with a massive, with a useful database of different exploits and vulnerabilities. It's checking how the system responds. And then it says, based on the response, let me check my database for different keys, different parameters, different strings, different banners, different ports to now provide information, useful vulnerability assessment information back to the user. So DVWA, and then let's go ahead and hit play to launch Metasploitable 3. So now Metasploitable 3 is running. DVWA is also running. I mean, the scans for those. This is going to take a little bit. So let's go ahead and minimize this screen. minimize, and then we'll come back to that in a few moments. Okay, I'm seeing in the chat, Hatlin, API disabled pop-up came when I tried to add basic scan. Now it won't go away at all. Okay, that is a very interesting feature. Got it. Is anyone else having this same issue? Did you all get an API disabled JS pop-up? API disabled JS pop-up. I wonder if it is a security thing. If it is a security thing, let's see if we can try and resolve that. Okay, if I click on the right side here, right side, let's go to preferences. And I'm not exactly sure myself yet, but we'll see if we can try and find any type of security settings. Okay, thanks. Thanks, Odd. Okay, privacy settings. All right, so this is fairly standard. Okay, send websites not track. I don't care about that. Delete cookies, login password, forms, autofill, address bar, permissions, block pop-up. Okay, so it's not an issue before, but if you're having this, try and try and see if it's the browser, like disable these settings. Block dangerous, deceptive content. Let's go ahead and we want to see everything. And okay, let's see if that has an impact. Okay, so let's close and try your scans once again. And if not, then just as Odd said, restart the Nessus service. If we have the instructions at the top there for sudo service Nessus D restart, and we'll see if that has an impact. And if not, I found it clear. Okay, now it works. Okay, so you cleared all the thing in Firefox, and all right, yay, that's great. All right, good. Well, I'm glad there's peace on Earth. Where peace on Earth has been restored. Okay, so let's continue in the analysis. Thanks. Yeah, again, sorry that happened. It's just one of those weird things like that. All right, let's go back to our previous slides. So we just finished 3. I want to say we just finished number 3. Where's 3? Yeah. Oh yeah, there's one more I wanted to show you. That's true. Right. Skip fish is done. Yay. Some notes that I put in for things to look at in Skip fish. I also want to point you to an open source framework tool. So this is just GWiz, not GWiz, but it's a pretty cool resource of things that appear in a tree, and then you can search, you can learn more from different resources out there. So the open source framework, this one's focused on gathering information from free tools and resources available online. There's also more data that might cost money using this framework, but at least the basic information that can be gained and learned from, like where do I continue from here? We can look through some of these open source framework resources and then decide to study more in certain areas. I want you to have that as a resource in case you haven't seen it before. Okay, so I want to bring up my browser. Yes. It's in the chat. All right, so that's just the slide that we have on our slides. And here, once it loads, there are different types of, areas of expertise or subject areas that we could search further. Usernames, for instance, in like usernames, passwords, search engines for usernames, we can expand the tree in those areas, and then we can start visiting each of those resources. We're interested in email addresses, Who owns email addresses, email address searches? If you have a random email address, who might this be? Is it malicious? Does it belong to phishing individuals? We can expand email search, and check any of these sites here, and learn more, see what's useful. Now, spoiler alert: not all of these links are still active. Some are active. It just depends on when the framework is updated to remove old things, and then others are added. So this is one that I use, domain name, because I do threat intelligence. Like these, I have these screens off in the back, but I think day one, my threat intelligence engines out there is downloading malicious data, searching for people, seeing what's out there so I can learn, I can do some big data analysis against it. So I can use some of these sites and references to help enrich data sources where I can download things from. So domain name, who is records, different spots and sites to get who is record information, subdomains. Let me just like different subdomain scanning, also subdomain lists, as we go through the directory traversal to see where we are in a specific directory, moving to the right for different resources from that directory. But there are also subdomains from specific domains, and that's a different type of scans that these may be able to help us with. Right? Vulnerabilities, different vulnerability discovery tools and scanners. IP address, show stuff on IP address, and just random thing like public records. I mean, you can even do like public records, property searches, and it works in the US here. And if you want to find like, hey, who owns a particular house, you can actually search public records to figure out where people are, where they live. Because unfortunately, part of the attack and hacking is not just the technical, but it's the people, it's the wetware that we also might want to see, hey, what can I do? What might I be able to do more from where people are, and how we can exploit. Maybe I can go to someone's house, they have kids or something, and I can perform an attack like candy appling or USB dropping. I forget what else it's called, but I know it as candy appling, in which I have a USB, something that looks nice, a free tool. I can just drop a few out of someone's house, drop a few in the neighborhood, and people are curious. And at least definitely back in the day, some would install this, plug the USB into the computer, but it has my malware that's going to auto run. So that could be a way that I can compromise the user. And now from the user's machine, I might be able to pivot onto the protected network, just different ways that we can search and gain more information. Because hacking is not just the technical, let me throw an exploit at something. All right, dark web searches and different websites on dark web, different tools that are useful, open source automation tools. I mentioned threat intelligence. That's a field I am highly interested in. And so threat intelligence, phishing, and then different sites. Like if you wanted to find out, are these people phishing, or learn from how other people have fished and see, okay, learn from others and enhance your tool set. You might be able to do so. You can learn more from various resources. And then there's a geolocation. Yeah, so there are various geolocation tools. In case you have an IP address, you're like, where is this IP address originating from? You can use various geolocation lookups. Like there's maxmin, where are you? Coordinates map, mobile cover. Yeah, so expanding, there's different databases that you can also download and check. Like maxmin has a good free geodatabase that you can download IP addresses and then search to see location of where servers are. There's also an IP2 location site that they provide good information. So, this is just wealth of information to check out. I want you to be aware of this, as it could help you learn and advance more in your trade. All right, that is all on this. Are there any questions with this deck? All right, I am not seeing any questions. Very good. Let's move on to vulnerability scanning. Give me 1 second. Let me configure. good. All right. Oops, clicked on something. Sorry, PowerPoint wants to access the internet. Thank you, PowerPoint. PowerPoint, all right. Thank you, PowerPoint. Okay, there we are. All right, references, credentials, once again, we're all familiar with this. Once more, please be careful with the knowledge, use it carefully, only perform scans on systems that you own and or have permission to assess. All right, continuing in our vulnerability assessments. I believe we spent time going through Nmap's vulnerability assessment scan yesterday, the external scan. I'm pretty sure we did. Because inside the scan, it gave us the website for vulners. So the vulners Nmap scanning engine was the one that is utilized as part of the external scan category. I moved it to this section because it definitely gives us information on vulnerabilities. Okay, if I look at those results, scan, share, vulnerability scans. Let's take a look at Metasploitable 3. All right, let me bring this over in Notepad. All right, so if I look at this, one of the scans from yesterday. Oh, in fact, sorry, exploit scan. Sorry, I want to look at external scan. It's not external. There we are. All right. So here in one of the external scans, so the commands to run the external scan, we did this one before, so that's why I'm not just showing us as a review. So nmap sv -- scripts external, and then the IP address that we're scanning. .h3, so this one is the DVWA machine, and then using the -OA, the OA gives us the outputs in all formats that Nmap provides output information in. And so those formats are your greppable, your Nmap base format .nmap, and then an XML file. And we will see what we can do with those XML files today. It's in a few slides from that. So the thing I like about the external is that it utilizes the vulner script. So vulner script, you have to use additional commands to get this script to run. But it's like, well, if external does the exact scripting for us, use external, and then in a few moments we will also execute the vuln VULN script on Nmap. Right. So as we're looking at the results here on this particular port 21, vulners Nmap scripts, it identifies the FTPD version 1.3.2c might be susceptible to these common vulnerabilities and exposures, your CVE, and then there are different types of CVE databases out there, like the EDB ID, and do we have AIBA on this one? EDB, CVE, Packet Storm. Okay, and Saint. So Saint will also provide similar vulnerability databases. So what we do whenever we see things like this, especially, we check out its vulnerability index. The larger the number, the more susceptible this program might be to attack, some sort of exploit, some sort of attack. And this one says it's a 10 and gives us indication of exploit. So at least off the bat, we start writing these things down and saying, okay, this is something that I'm going to look after and exploiting and just giving it a try. Can I gain access to a system? Now, accessing computers is an art and a science. If we are just using the base open source tools off of Kali, I have Kali, I've updated my Kali database, I ran a scan, I see something that's a 10, and I try and attack this thing in the real world, 9 times out of 10, it's not going to work. It shouldn't work because the vendors of the same tool that you are using, they also are using the same tools that you are, Kali, to exploit their own system to see, is there a new vulnerability out there? Oh, we just found something new. Let's go ahead and fix this quickly, relatively quickly, so they can try and save face from being on the news. But sometimes you do find things that will work. Other times you, from searching things, like exploit database, we'll visit that in a few slides from now. We can see that, here's a new vulnerability, like SolarWinds is on exploit DB. You can download that vulnerability, incorporate it into an attacking framework like Metasploit that we will use, and then you can also try and gain access to a system. But it just all depends. Okay, so if I want to look at one of these, I'm just going to highlight that and visit that website here. I'll bring up my browser. So here again, we're just looking through the results that it provides. Okay, just as we did yesterday, reminding us that this is the process that we'll see. See a description of some of the code that could be susceptible, and provides the CVE. So I definitely like looking at the CVEs to see, okay, what is truly malicious and not. And then in exploits database, let's see if we can pivot to exploit database now. No. Did I click on the right one? Deviating. It's fine. We're going to get to exploit database. Anyway, on exploit database, I'm going to show you that in the, like you said, at the right side or so, you can download the exploit, and then it will also tell you, like, hey, is this ready and Metasploitable now, or do we have to upgrade our Metasploitable Metasploit machine to carry out the attack? Nice, Enoch. Very, very good. I haven't gotten to that CVE just yet. Okay, so external scan, definitely one to use. All right. And that's pretty much the rest of how we look at these vulnerability assessments. And Vuln is very similar. It's just some of the results, there are different databases. Some databases are less noisy, give less false positives than others. I like Vuln, the Vuln script, and that runs in that. And there's one more. There's Vulners, there's Vuln, and then there's one more script. I can't remember the name exactly. Vuln scan. Yeah, Vuln, VULN scan. So Vuln scan, I think, is an older deprecated scan at this point. But that one had more false positives, at least whenever I used to use it in the past. So Vuln is pretty useful. Okay, so let's go ahead and launch one of the scans here. That's good. Our Nessus scans have completed, so we will come back to these very soon. Okay. So here we are, just entering, let me put it in the chat. All right, it's coming over to you. nmap-sv-v, want to be verbose with these commands. -- scripts, we're invoking the nmap scripting engine. Vuln, using this category of vulnerability scanning scripts. -OA, nmap, vuln, DVWA, and then the IP address that we're going after for DVWA 169.254.8.h3. And while that one is running, I'm just going to open a new tab. This file, new tab. In fact, I'm going to copy what I put here. Copy. And in our new tab, save at the same share location. I'm going to paste and then just make some changes. So instead of this being DVWA, I'm going to change that to Metasploitable 3. Metasploitable 3. 169.254.8.81. And then enter. So now we're running through different scanning mechanisms to try and build that scan table. Oh, I saw something that said lacked privilege. What did we just do? You shouldn't scan. Okay, firewall bypass lacks privilege. In fact, I'm going to stop that. So we can just make the change real quick. We haven't gotten far. And let's add sudo to the scan. Here, if we go back, we add sudo to this scan. Let's do the same thing here. And just adding sudo to it. Cali, and then hopefully this should not give us the errors that we just saw previously of lack scanning permissions for the firewall scan. Okay, we're just about at the top of the hour. So how about, as this is running its scan, let's take a 10-minute break. We will come back in 10 minutes, and then we'll continue from this standpoint. I'll see you soon. All right, welcome back. Hope the break was good and restful for you. All right, let's go ahead and continue. It looks like at this time, our scans have completed for Metasploitable 3 and DVWA. Excellent. So now we can go right into the analysis. Before we continue, I want to make sure, Mike, can you hear me and can you still see the screen? All right. Okay, excellent. Thank you very much for the confirmation. Great. So very similar to how we went through the external scan, we have the specific vuln scan that we have completed. Now I am going to bring that back over here as well. Okay, let's use this one. All right, so I would like to go into our scan, our shared drive. In our share, let's look at DVWA first. So I'm going to bring over the nmap file. And now, as we read and understand some of the things that it's saying, some of this is what we saw before. So we have the different scans, and it says it's vulnerable. It might be vulnerable, but this is a very old CVE, very, very old, so I don't expect it to be vulnerable today, but it might. Some of these vulnerabilities resurface sometimes, and it is possible. But that's what something we might take a look at. Looking at other vulnerability. So SSL, it could be vulnerable to a man-in-the-middle SSL interception / masquerade, cross-site scripting injection attack. Okay. We did this yesterday, Diffie-Hellman, SSL, Poodle, and MySQL. So this is, I can't remember if we spoke about MySQL yesterday, but this is one of the vulnerabilities that might exist. So what we do, we Google this vulnerability and see how do we exploit. Let's take a look at Metasploitable 3. For Metasploitable 3, RDP might be vulnerable. So as I'm reading these, I'm just going to take some notes like, hey, 3389 might be vulnerable to remote desktop protocol denial of service vulnerability. And is based on the particular type of exploit and packets that you can send that can cause it to go offline or to consume its resources such that it is degraded or denied access to others. Remote desktop, vulnerable, CVE there. Another vulnerability in the key exchange. Diffie-Hellman. We saw these before. Vuln. All right, so this one is interesting. This specific HTTP vuln CVE. It says this system might be vulnerable. But if you Google this CVE to learn more, or Tenable, which is our Nessus plugin, we will very likely get to see that again. The enum works here in this scan. You know, sometimes it works, it doesn't work, it luck of the draw. In our HTTP enum, is able to find a tbook.csv, snom iPhone, excuse me, and also this directory. So directory traversal is possible on the Windows side. That should not, you know, definitely not good. And all that is off of port 8022. So let's go ahead and look at that. It's like, okay, so we have found something, port 8022. Let's see what we're, you know, what our results is indicating to us. All right, let's see if we can find this. Here we are. Let's go back into our interview. Firefox. Okay, these are some of our other items that we're looking at before. I'll go ahead and close those. And Skipfish, I'll just use this. You can use whichever tab that you would like for the analysis. I'm going to go to HTTP 169.254.8.81 because this is our Metasploitable machine. Can't paste into it. / from our scan, it says tbook.csv. Did I make a mistake here? Oh, I'm sorry, the port. So this is on port 80. The port that is supposed to be on is port 8022, 8022. All right, so this brings us to one of the systems that's running up there, Manage Engine Desktop Central 99. All right, so now we have a login page we can't get past just yet, but it is possible to see if we can exploit this entire thing and potentially gain access to that system. So more to come on this system exactly. Okay. It's also giving us that there is a CWHP. I'm not sure if we can get to that yet. CWHP. Oh, that's right. Okay, so it's showing up as a specific traversal. Let me put that here in the chat. Because that would that's going to take me some, nope. One second, let's see if we can get that to work. So that is going to be in our command line. It's our Metasploitable. So let's go up to port 8022. We'll take a look at that one also. Let's see. So here we are. This one. Let's see if we can get this to bring information to us. So copy this selection. And again, it's on port 8022. Let's see if we can get something to happen. It wants me to go through that conversation. All right, I remember I got through that before. I'm missing a step. That's fine. That's fine. At this point, it's still okay. Just looking at different aspects that are interesting to us to see, okay, can we get past something initially or not before we do the exploitation of it. This is also 8031. SSL is unknown, but it has a poor key exchange. There's something running on port 8080, Oracle Glassfish, port 8080. Let's see what that looks like. So it says, you know, it's giving message information that should only be internal, but it's leaking this to, you know, anyone that's able to scan it. Your server is now running different information about it, and then it's glassfish in particular. Let's go back. I'm gonna close this. Okay, in the enum here, enum was good. Possible directory path traversal. Let's see if we can get to this one from port 8080. I'm not sure, but we'll give it a try. We'll see what happens. Gonna talk about it? I don't think I 1 second, here we go. There we go. Okay, it looks like I still couldn't get access to that. Let's see. Oh well. I didn't copy properly. That's if you wanted to spend more time, we can try and make that work. Let me see. Mm-hmm. Mm. Very good comment there on the admin. DOS attack is possible. 8181. Possible transport layer insecurity. So 8181. What does that one look like? 8181. Okay. Possible bad security, because that's what that warning was telling us. So if we get a message like this, we just go to advanced and accept the risk and continue. And now another glassfish server is running on this 8181. Okay, let's see if there's anything else useful to us. Likely vulnerable. Another service, 8443. Let's see, what was that? 8443. Let's take a look at that one. 8443. So there is a server responding to possibly like raw bytes or so. So I'm curious, in case you see something like that, it's something that is just not interpreted by the encoding on the web page. We might have different luck if we connect with something like a netcat listener, or we have just raw byte exchange, or maybe it's like an SSH client. I'm not sure. So just out of curiosity, if we open netcat, we go to that IP address, 169.254.8.81 on port 8443. We might see if we can, dash P, I think, sorry. Dash P 8443. We might see if we can connect, no, force to connect. Use a space. So nothing that we know of just yet how to connect. It could also be SSH, perhaps. But that's not going to be on the same port. Nah. We're not sure just yet, but at least this is just something that we see like, what could that be? We'll try and connect out. All right. Another port, Elasticsearch here. And notice that there's a specific Elasticsearch version, 9200. Let's take a look at what 9200 is like. So 9200 is returning us JSON, a JSON tuple of information here. raw data, headers. Okay. That's interesting. At least we're finding many different web servers that are out there that we can try and connect to and provide that those details here. Okay, then there's also something on 9999. Again, it's that Abyss server we tried to connect to before. And others, remote procedure calls, RPC, on these ports that we don't necessarily recognize just yet. Okay. All right, and that's the vuln scan. So at least with the vuln scan, and then with the external scan, we can start to build up. That's like the free, very free, not pretty vulnerability assessment. So with those, already we have enough information to begin Googling those CVEs, and we'll check how do you specifically exploit this CVE in exploit database or a separate type of exploit website like packet storm. Then seeing how to exploit those vulnerable systems that just Nmap can show you. You can see maybe you can gain access to the computer system even before you use the pretty vulnerability scanners. Okay, with that, did I miss anything? Or was anything curious to you that I did not highlight, at least from our Nmap scans here? Okay, not seeing anything. All right, so we did that. Let's talk about exploits DB finally. I'm waving my hand around about exploit database. What is exploit database? Well, exploit database maintained by Offensive Security. Offensive Security, pretty decent company. Like they do various tools that they release. They maintain exploit database that a lot of us use either directly or indirectly when we go about hacking and attacking machines. They also have different types of certification programs, different certification courses that you can take to grow in your cyber, analysis expertise. All right, so back to exploit database. Database nonprofit product that is maintained as a public service by Offensive Security. It is CVE compliant, in which there are many CVEs that can be disclosed, and it is compatible with the right protocol to display the information back to the user, and also to aid with searching and being compatible with the other tools to interface back with exploit database. And then its aim is to serve as the most comprehensive collection of exploits gathered out there. And it's a really good source. So in essence, I want to hold all of the databases, or at least information to vulnerabilities, database to hold these vulnerabilities, and people can now come and use open source. You can add information, via their cooperation agreement, etc., to grow in knowing what exploits are available and present. All right, let's navigate to exploit DB. To the website. This is generally what the exploit DB looks like once you go there. I was also mentioning that yesterday or so I saw Solaris, I saw SolarWinds was in the database. So anything that you are looking for, like for instance those CVEs that we found before, you can come and search for it right at this site. There were a few references to Apache that we discovered in our scans. We saw there was Apache and then version 2.2.14. So we can actually scan for what do you know exploit database about Apache 2.2.14. And every time when I say, oh, that's interesting, I am interested in saying okay, is there a database? Is there an exploit for this? Just immediately pivot into exploit database and determine. If so, you add it to your list of potential attacks to throw at the vulnerable system. So here we are. If we enter an Apache 2.2.14, it will process the scan. And then any type of exploits that it knows about, it will display it for us here. So here, this one goes back to 2010. If I click on the title, now I can read information about the exploit. This is the exploit code that gets to run. This is the shell code. Oh, and they even say shell code there. That's really nice. And this, in essence, if you were to download a compile, you can execute and launch it against the vulnerable system and see if you can take control. Then also at the top here, overall, I'm looking at the CVE number. So this is the CVE that this one has a vulnerability against. The CVE has been reported. This is another type of exploit database ID. Author type, the platform that it runs against. Okay. Vulnerable applications sometimes will be filled in here. It is verified because, as I mentioned, people can submit code and submit exploits to ExploitDB. And then once it's verified, you know that, okay, this has successfully launched. It has run at least some points in the past. And then at this side, you can actually download the exploit. The new exploits that people put up there, like this is incredible. You can download it. Download, save to your machine. Many times you can find code in different languages. So this one is written in C. You'd have to recompile it. Other times you get code written directly in Python, or more importantly, in Ruby. It's either Ruby or Perl. I think it's Ruby. One of the languages that is immediately importable for Metasploit. So you can download new exploits that aren't even in the database yet, add it to the Metasploit framework, and then you can already start using this exploit on other systems. That's why the Metasploit, as we get to, is a framework that is extensible. You can add more tools to it and use it and grow as necessary. Okay? But overall, this is how you build that information to know how to launch the exploits. Build first, know the foundations, and then everything is a variation on the theme from that. Okay. Let's see. I was also, I'm not in the machine. Something else here that whenever it gives you like the CVE number, I want to just search for one and we can read more on exploit DB. Okay, so this one is 2012-1182. Okay, so this is an SMB attack, remote code execution. So this is the CVE that we're discussing before, CVE 2012-1182 that Nmap was able to show us. So from Nmap, you can see that, there's a potential vulnerability. Come into exploit database to read more about that vulnerability. You can see set information, policy, audit, events, heap overflow for Metasploit. Excellent. So this might be a potential way to exploit that machine. And if it's not in Metasploit, and we'll do some searching on that in a few moments, but if it's not in Metasploit, then you can download it here. Download the code. Yeah, did I say Ruby? Yeah, so Metasploit. So this one is in Ruby format. So here you can already just download it and import it into Metasploit if it's not there already, and then you can begin throwing this against vulnerable machines. So that's exploit database, an online database to do scanning. Now, a question is, wouldn't it be nice if, like, when you're on the run or you're working with air-gapped systems, computers that you just don't always have access to the internet, you still want to perform this type of scanning? What's in the database? What exploit might I be able to throw at a vulnerable system? So there is a way to do searching. And the tool, I was talking about it yesterday and the day before, Searchploit. So this is where we get to work with Searchploit. So what is Searchploit? Searchploit is it's a command line tool for an exploit database, exploit DB, that allows you to take a copy of the exploit database with you everywhere you go. So you update the Searchploit database. It's updated with the known vulnerabilities from exploit DB, And then anytime you're on an attack, even away, no internet access, or with your current machine with internet access, you can immediately pivot into search exploit. Is there an exploit? There's no exploit. All right, I'm not going to waste my time going through the steps of Metasploit yet. I can search again. Is there a potential exploit in search exploit? Oh, there is one. All right, let me launch Metasploit and see if I can throw an attack against the vulnerable system. As it indicates, it will search for exploits and shellcode available. It gives you the power to perform detailed offline searches through your locally checked out copy of the exploit DB repository. And I mentioned it's useful. It's particularly useful when you're in a segregated or air-gapped networks. Your machine might have connectivity to another computer, but you don't have internet connectivity. So it's good to know this right now that, okay, I have something that's I'm ready to throw. And you can try and gain access to a victim, a target machine. And then I put it here as possible use cases. So there are ways that we can search just different keys. If you want to update your machine, app updates, app full upgrade, just update the computer. Your exploit database should update on its own. Metasploit should also update on its own based off of that. And if you specifically want to give it the directive, the command is searchploit-u for update. Okay, so let's go ahead and do a couple of searches with searchploit. Okay, so here we are. I'm going to take my computer at this time. Let's go ahead and clear. Oops. Clear. And if I type in searchploit, just searchploit on its own, it launches the help and shows like different use cases for searchploit on the Kali Linux machine. I can enter in different searches and specific keywords. So it is a string search. So if you enter in multiple words, one word space, another word space, another word space, it may look for each of those words individually and collude a list for you that you can now sift through and see, is this useful? So to search is one way, search exploits. And then let's type in Apache. I can first just say search exploit Apache, and then all of the available vulnerabilities for that have Apache in its name will show up here. So now I'm looking at the exploit title and then the path. Oops. So I have the title to that exploit and then the path of where that exploit is found on the computer system. So some are specific .c programs that Metasploit is able to interact with. Others are text files. I can't recall what .pl is offhand real quick. Perl? Most likely Perl. Others are Perl, and then there should be Ruby, and Ruby extensions. If we want to be more specific, we can say Apache, searchploit Apache 2.2.14, 2.2.14, because this is specific from what we identified from our scan somewhere. So, kind of the more specific you can be, the less results that you have to sift through using a tool like this, searchploit. So now at this side, it's saying Apache 2.2.1.4, exactly what we are interested in. And so if this was like Metasploit, so if this was Metasploit that we're already working on, we can see that this is a potential exploit that we can try. And in Metasploit, we would do that same search, Apache 2.2.14, and then we would start to use that exploit and configure it to launch against the victim machine. All right, there's also a way to automate this. So searchploit, instead of having to go through one by one, even whatever we analyze, this is why I was mentioning the XML file is very useful in our Nmap scans. So on Nmap, if you know where your operating system scan is, if not, we can create another operating system scan real quick. So the scan for the operating system, Clear. That command nmap dash a. Let's use dash a versioning and add us a few extra scripts out there. The system, let's do DVWA. Yeah, it should take less time to scan. 169.254.8.83. I'm going to say insane scan as fast as possible, -T5. And then let's say give us the output in all formats, including XML, -OA. If you only want XML, I believe that flag is -OX, just specifically for an XML output. Let's name it again, nmap just nmap -a _ DVWA, and we'll press enter. And so as it's running through the scan, see really fast, our scan file, the XML is right here. Oh, okay, we did that for vuln, for the vuln, which we'll do in the next example. But for the operating system in particular, operating system file is nmap-a right here. So now let's launch that immediately to be ingested in searchploit. So to do that, your command searchploit --nmap, and then the path to the file. Okay, you have that command in the chat. So that will just be searchploit --nmap, and then the file that we want to use. So that was nmap -a, and it was dvwa.xml. I'm just using the tab complete. So I'll pause here for a second. So we're launching the XML file that we do scans from nmap. We're ingesting that into searchploit to have searchploit automatically scan for us and then determine that, hey, here are some potential exploits you might want to consider as you exploit the machine. So instead of us having to type it one by one, we can just look at the results that searchploit can provide for us. So again, this was the command here. It's also in your chat. Searchploit --nmap, -a, whatever we named it, dvwa.xml. And now as it is searching for us, searchploit provides results. Now it's a string keyword result search, meaning it might not always match the exact, the full versions. It matches portions of names that it found useful in the file that you have given it to produce a potential attack entry points for us. But at least from our Pro FTPD, the Pro FTPD version, I want to say is version 1.1.1. And then we can look in what exploits might exist, and then we add it to our list of potential attack vectors onto the victim machine. This is Pro FTPD. Here is the SSH one that we saw. And in the scan, I think it's SSH, is it 3.5? I know there's a P in there. It's SSH something P1. So these are potential and specific exploit titles that we could use. It's showing some of the Apache versions that it saw in this specific scan. And then other keywords. So I mentioned it's a keyword search. So these HTTPs, not necessary, these are not useful to us because it has like Python, CGI. We didn't see any of that in our scans, but it just matches keywords. So you do read, you sift, you see like what is useful and not, and then you keep the useful nuggets. Let's go ahead and do the same thing with the vuln scan. Here I am, I'm going to use nmap vuln, VULN. And now with our vulnerability scan, let's import the vulnerability scan for Metasploitable. So vuln Metasploitable 3.xml. Okay. If I say OK, SourcePloit is analyzing that entire file and then it's producing results for us here. And then when it's done, we can take a look to see like what all is possible for us. So if I scroll up to where we initiated the scan, is right here. We can start to go down similar, but there's going to be more information because this scan should have provided more details to us. Open SSH, Microsoft Windows here. Go down from it. But Google appears to be hogging my system resources. Okay, well that was fun. I should be back. Sorry, I apologize. It's one of those things that happens with virtual. So my Chrome wasn't working properly. Let me go ahead and share my screen. Okay, I am back. Hopefully things are running properly. Looks like my video is good. Voice and audio, can you hear me and can you see the screen? I apologize for that. I don't know why that happened there. My mistake. All right, thank you. Okay, so before, as we were looking through the scans here, seeing what is possible, what's out there, we're also just keying in on what does SearchBolt have for us, and so we're taking notes. We also like to see things like open glassfish, excuse me, Oracle glassfish. We'll see if we can exploit that one today. And that's a good one, as well as I think that's the last one. Is that no? Yeah, Elastic. Okay, so finally here's some Apache things that it did discover. Elastic, it sees that there's vulnerable Elastic searches that could be possible for us to go after. Elasticsearch, remote code execution for different Elastic search engines that are out there. And now we finished with SearchBolt, but it's pretty useful to quickly check and then continue on in our scans. As we analyze like what are we interpreting from the scan. Excuse me. All right. Yes. Okay. This is a fun one. All right, so here, just have notes on the exact steps that we just took to look through SearchBolt, along with Metasploitable 3, and then, the comments and the words, and I like seeing highlights here. Let's do another scan. So there are different types of vulnerability scans as we build into getting to Nessus. We build into Nessus because that one is not, it's free, but it's not free. You have limited number of scans that you can do, certain timing, and at the same time, Nessus is here today. It might not be with us tomorrow, but it's good that, as I mentioned, as experts out there, our capabilities should not be dependent on a tool. but rather we should know how to execute many tools to amalgamate this specific capability that we need to carry out the attack. So in this case, let's go ahead and launch a NICTO scan, a NICTO vulnerability scan against the vulnerable web server that we're checking in DVWA and see what the results look like. Right? So what is NICTO? Open source tool that NICTO has been around for a long, long time. Ever since I got into cybersecurity about more than 12 years ago, NICTO has been there. And so it's a really good tool, and I like using this as part of that initial information scan on the victim machine. So it includes over 6,700 potential dangerous files, and it continues to grow as new vulnerabilities are added to the NICTO repository. It also checks for server configurations and different types of utilities, different header files to say, like, this system might have a poor configuration that could lead to directory traversal, remote code execution, the cookie is not protected, flags are missing. Similar to, remember yesterday we went through what web, that gave us like that initial scanning of a system. We could see some of the potential vulnerabilities. NICTO is specific for that website vulnerability scans. So it goes in further detail. Yep, so some items, scan items and plugins are frequently updated and can be automatically updated into NICTO. Right, so here are some commands that we are about to run on NICTO. I will place them in your chat. Yeah. Okay, so here I am. We'll go ahead and type in our commands here. NICTO -H. Ooh, let's do this against hackon.org, and it's going to take some time, but we'll see what that looks like. Hackon.org -P, looking at specific ports, to save us time. Port 80, and then 443-C. For which parameters are we looking for? All of them to do in our scans. All. And then we're going to write append to a new file, and we'll name that NICTO _hackon.txt. So we're doing a NICTO scan against hackon.org. That may take some time. Let's launch 2 more scans against our DVWA and our Metasploitable 3 machines. So I am just in a new tab, file, new tab. I'm just going to write. I'm going to write this one, NICTO -H 169.254.8.8.83. That's the ports that we're going after, 80 and 443. Big C, all. And then I'm going to save this to NICTO. Let's say NICTO.dvwa.txt. All right. We'll hit enter. We'll let that one start its scan. And then let's do this for Metasploitable 3. Metasploitable 3 is going to have a few more ports because we saw that there were a few more ports in our open scan. Right? Our scan had many different ports, and we could access them and see that a web server is responding information to us. So we would like NICTO to also perform assessments against those and potentially find vulnerabilities. So that command, NICTO -H 169.254.8.81-P 80 443 8080 8383 7676 3000. There were a few other ports. Trying to remember them offhand. 7676. Oh, 8022. 8022. I think there's an 83. Yeah, 83. This is good enough. So at least let's start some NICTO scans here. That's big C. all, we'll save it to nicto underscore metasploitable 3.txt, and we'll hit launch. Okay. Now we'll come back and check. It is going to take some time, but at least our DVWA has completed. So with DVWA complete, let's go ahead and look at the results from nicto with DVWA. Okay. Close. nicto scan is right here. Just kidding. There we are. All right, so this is what the nicto interface, or at least the results, looks like once it's complete. Okay, and that's fair. So it says I didn't find anything running on 443. Just want to make sure the IP address is correct, 169.254.8.83. That is correct. So again, you notice that I always check IP address, because it's happened. I've hit wrong IP addresses before. So I was like, well, always just confirm and verify that we're looking good. Okay, target IP address. IP address is good. Target port 80. Start time. Now we go through again line by line to see what is good, what is useful. Server Apache 2.2.14. We write these ones down to say, okay, hey, found some interesting headers. Immediately, whenever we do this, remember we pivot into searchploit to see, okay, searchploit, do you have any potential attack vectors or exploits for this banner that we're uncovering? So we have Apache. Just writing this down on my list of things to go after. Apache 2.2.14. PHP version 5.3.1. Anti-click jacking frame X frame is not present. We can see, okay, click jacking. I believe this is one that I can open up a separate tab, and then I may be able to compromise your browser. I think that's what that click jacking vulnerability is referring to. Cross-site scripting is not defined. Okay, so just poor indications in the network packets that should have had information alluding to this fact. The cookie doesn't say HTTP only, but HTTP only, HTTPS, it doesn't say that. Root page redirects to login.php, it's fair. Server may leak inodes via etags header from the file robust.txt. So we may be able to gain information about the actual files itself from the header file. Here it's saying Apache mod negotiation is enabled with multi views, and so it tells us that this could allow attackers to easily brute force file names. So try and brute force file names, gain information from the server, and then we can search more. We can go here to read more about that specific type of attack, and then if we see something like that, we start Googling how do you engage multi-view, or how can you perform brute force file names against this type of server. Like, that's how our hacking is. You uncover something, you Google, and then see how you can employ it against this specific environment. And this is nice. It's saying that Apache appears to be outdated. The current one is at least Apache 2.4.3.7. So on our side, let's say that we owned this Apache web server that we're using, to host our services. We routinely scan our systems to see, are there any new alerts? Are there any new patches, updates that I should be aware of? And this can also help you say, like, oh, a new version has now been released. We haven't updated our old version. We should probably consider that. Okay. SSL appears to be outdated. Perl appears to be outdated. Okay, again, the Perl that it's responding back to us appears to be outdated. So this machine needs to go a makeover of updates. More things that are outdated. OpenSSL appears to be outdated. Now here, this is our, it's like a vulnerability similar to the CVE, like it's a specific index to a vulnerability that we may be able to compromise the machine or carry out some effect. So not every vulnerability out there is a compromise, a remote code execution. Some might allow you to perform directory traversal, bypass, login, insert a new credential in a malicious or poorly written database, delete databases. It all depends. So just what I would do, as I see that entry, I would search for it. All right, so I'll do a Google on that. This is bringing us back into our vulners.com. We're looking at the specific entry that we saw from Nikto. And then here we'll read information about the vulnerability description. RFC compliant. Servers should support certain traces. This one is not doing that. Could lead to unauthorized information disclosure. So directory traversal, I might be able to do cross-site scripting. It all depends. And now different references according to that. Exploit database, Metasploit. Because Metasploit is one that we really like. So in Metasploit, there are scanners. So auxiliary, that's a hard word to say, aux scanners. And if you use the aux scanner, you might be able to extract information from that system because it's not configured properly. So also one of the things we'll write down, are different types of exploit features we could use. So this is auxiliary scanner. HTTP options. And you see what you get from there. Okay, this CGI print environment. Okay, so site appears to be vulnerable to shell shock vulnerability that existed before. Like, oh, shell shock, that was a good old one. But with that, you can see additional information about that. I just copy and pasted the link that Nikto provided to us in his vulnerability assessment. I can read up on the CVE, and you see a description about it. Lots of references, and then I also see exploit DB. Let's pivot into exploit DB. So here we are in exploit DB. We're looking at the shell shock. The specific to this open VPN version, just in case. Now, the verification, this one says not verified, or at least you don't have a confirmation that it has been verified. So it might not work as well, this specific exploit, but there are many others. And if it wasn't in our Metasploit database, you can download it here, text file, and then incorporate it into Metasploit. Okay, so now we'll continue reading some of the results from Nikto. All right, so that one again, config directory indexing is found. So as we love finding index of, so it's like, hey, I found the directory indexing at this, at this location. So config possibly could do directory indexing from that spot. Config may be available remotely. Okay. This PHP, it might reveal potentially unsafe information, specific stuff about the query strings that we're providing. So you might be able to modify that, okay, and send this additional commands to take over that machine or cause some functions to occur. Okay. Server status. So server status information that is revealed, I think we saw that yesterday, or if not, it was earlier this morning, afternoon for you. Anyway, it is revealing information that's like, wait, this should not be revealed to the public. The attacker, I should never know your specific Apache version that you're running. I should never have that information. But if I did, now you can be more specific in the exploits I'm going to launch against your system. So that's why when you can uncover these in your scans, you want to hide. Apache do not show this, or you alter what Apache would actually show to an individual. Because the worst thing is Apache's like, hey, I'm Apache 1 point something. The attacker like, oh, Apache 1 point something, and tries to launch an exploit that's not compatible, if anything. Okay. So this is great. Remember yesterday we saw the PHP my admin file from one of our scans from Nmap, and was like, whoa, PHP my admin is available. So you just say, okay, PHP my admin, huh, no problem. I wonder what I could do with that. And then when we browsed yesterday, we could see that you can go to the different tables. You can add users into that PHP my admin table. You can remove users. Various things that you can do against that. That was PHP my admin. I think it was. Yeah. So the PHP my admin is exposed. It's meant to be. Okay. So here, at least the Nikto is able to help us identify that also. Right, CGI, print bin, icons, directory indexing, changelog, directory indexing, admin login page is found. And some of the Nmap scripting engine scripts would help to try and log in. And that's how we saw that the password, username and password that was successful for login is admin password. Also, as mentioned earlier, the admin is also one of the passwords for one of the web servers. I think it was a Glassfish that you're able to log into. Then it gives you details about the PHP my admin README file. And then overall, it executed 26,000 requests against the system and 40 items. And all of that took 79 seconds. So that was pretty fast. One host was scanned there. So this is a really good scanner. Like this is de facto in epoch scanner to use as we search for vulnerabilities on the victim machine. Okay, on your Nikto scan, which one is it? Is it the one going after HackCon? Because that one takes a while from where we are. Let me see if mine is still running. Yeah, so my scan on HackCon has taken a while. The DVWA was fast. This one is going to take a while also. So Metasploitable 3, so yes, it does take a long time. It can take a while. Metasploitable 3 has many ports that are open and exposed to web. So Nikto, every time it sees one of those that might be a web service, it browses them to determine more information about it and launches different types of vulnerability assessments against it. So that's why it's going to take a while. Yeah, so this Metasploitable 3 will take a while. Hackon.org will definitely take a while because these things in the real world, especially depending on your distance, it's going to take longer. DVWA, that one did not have an issue. But if it is having an issue, just one of the things I would recommend, restart the scan, 1, or 2, or probably both. Actually, what I would do is I would stop the DVWA for sure. Go ahead and stop the scan. Restart your DVWA client, the DVWA virtual machine, restore it. It could have crashed because we've been doing scans before. And so the thing about scanning, especially when we're trying to do vulnerability scanning, the very nature of checking if a vulnerability exists might exploit a vulnerability, which means that service might die. It might no longer be able to work. It might become inoperational or non-responsive. So if you revert it, you can try and scan again and see if that fixes it. Yeah, Autumn, I'm sorry for the problem there with the scans. But just in case, we are in vulnerability scans, DVWA, Nikto. So in the scan drive for our Google Share, I included a already completed scan for Nikto. I think I did this yesterday. Yeah, I included a completed scan for you, so you do have this, present that you can look off of, and then on your own or later or even now you can rescan and hopefully it will work for you. Okay. All right, let me. Metasploitable 3 is also in the saved scans before. Yeah, I even think this one kept on running and I just stopped it. So it likely would have run for a while. It just stopped and being responsive. Like, okay, that's good enough. Let's see, some of the results that you have in Metasploitable 3. So here we are, Metasploitable 3. NICTO, the IP address that we are scanning, 169.254.8.81. Metasploitable 3 machine, confirm. I said I did not find a web service on 443. We gave it 7676, did not find anything. We gave it 3000, did not find anything. There are other ports that it did find information, and it tries to assess those. One of the first entries we see, Microsoft IAS, web server for Microsoft, but it's an older version. So that older version has issues that it might be susceptible to clickjacking attacks. The anti-clickjacking X-frame option was not present. Cross-site scripting protection was not defined. Allowable traceable methods, public methods, scanned, do not have any issues with this particular service on port 80. Now it's looking on port 81, no, I'm sorry, port 8080. Yeah, that's port 80. Yeah, port 8080. These are the aspects that it was able to uncover for port 8080. That is Glassfish. It appears Glassfish version 4.0 is running on port 80 on this Metasploitable 3. Allowable methods. And then NICTO 2 was able to perform directory traversal. I think I was just typing in, or I was pasting the command incorrectly to also perform this directory traversal. But it says posts can be done, right, to execute arbitrary commands. So that's so arbitrary commands. I can tell it, hey, give me your system information, like launch that. Perhaps if it's running at elevated privileges, I can say add a user, and I might be able to use that user to log in, upload a file to the victim machine and have it execute under whatever privileges is running there. Like arbitrary command execution, that's a wonderful thing to identify, and then we can start to see how we can interact with that system further. You can call it to ping, shut down, destroy, launch ransomware, so many things. Okay. Utility scripts might be able to be run arbitrarily from the outside onto that machine. Again, when I see something like this, I think of directory traversal. Yeah, you might be able to read by prepending multiple dots or characters. Directory traversal and backslashes, it's running on a Windows, from the from the web address, then you can perform directory traversal, that you can see information. Okay, this allows the user to retrieve any file from the system. So when I tried this, I think when I tried it, it didn't come out best for me. Metasploitable. Let me see if we can try that one more time. Going to the share. The screen the same thing. 1 second. Okay, this is good enough. This one at least has some of the entries that we're looking at. If I do cat on NICTO, Metasploitable 3. Okay, this is the directory traversal we're looking at. Let's see if we can get this one. I know I got it before, just something basic I'm missing. 169.254.8.81. port 8080. Yeah, I can't remember how I got that one to run before. Oh, I'll have to look at that one later. It's a good vulnerability to actually get to execute, because you can get it to execute. And your DVWA, you can also get it to execute. I'm just bringing back the Nitro file. This is the old one, the current one that we're looking at. Okay. And then again, some of those database entries similar to the CVE. And then a website that we can learn more information. So Bad Blue server is vulnerable to multiple remote exploits. So when we do see things like that, port 8080 is definitely something we're going to want to attack further. All right, scrolling down, okay, we're done with port 8080. Now it was working on port 8383. The 8383 server is some sort of Apache server that's running. Again, some of the flags and that are supposed to be responded and protected are not properly set up / protected from the remote system that we are scanning. Host does not match the certificate. Another type of CVE database that we can look up and see what the entries, gain more information, see how we can exploit it further. And then you just let this run for a while to uncover additional aspects about the system. The NICTO is a good tool to keep in our arsenal, and you can also automate it. And so that's even better with it being a command line tool. You can automate this in your own virtual scripts. So then you can say the Nmap scripts that you really like, automate those. NICTO scripts or NICTO that you like, automate that. What web you can automate, because I use the no color option in the what web. Yeah, it was like what web and verbose. So all of those are meant to be automated for you. So you can just launch a script, walk away for a little bit, come back and see all the results that we can start to analyze and to build that folder of what potential vulnerabilities are we going to go after on the remote machine. All right, are there any questions with that so far? All right, I'm not seeing any questions. So here, we're about to start looking into Nessus. But now, before we get started, let's go ahead and take a 10-minute break. Yeah, take a 10-minute break, come back at 10 minutes from now, and then we'll continue. All right. Welcome back, welcome back. Okay, excellent. Now, as we continue, I think it's been 10 minutes, right? Or am I 3 minutes early? I can't remember, I apologize. I didn't save the time on that one. Okay, excellent, thanks. All right, well, let us continue then, please. Nessus, so a lot of the work that we have done, has led us to this point of using Nessus. Okay, yeah, a lot of the stuff, as I said, has led us to this point of getting ready to utilize Nessus to understand its scans, because it's a beautiful looking tool, lots of information, but from the different scans, I don't think that Nessus, in this scan, I think everything that we're going to exploit for sure, we have seen it from one of the other scans that we have exploited, to this point. But it is good to also have Nessus in your toolbox In case it's going to work for you, utilize it. In case it doesn't work for you, you have all of the other tools to put together to still be able to carry out your attack on the victim machine. Okay, I'm sharing the screen. I want to make sure, can you see the screen, Nessus? All right, excellent, thanks. Okay, good. So let's talk about Nessus for a second. Here we are, proprietary. I told you it's proprietary. It does cost a good chunk of money, and to get the enterprise version, especially the number of systems that you want to scan, how often you want to scan, how much information do you want to be returned back to you, it's going to cost. You know, there's a cost for utilizing Nessus, but it does provide a wealth of information back to us. The scans cover a wide range of technologies, including operating systems, network devices, hypervisors, databases, web servers, critical infrastructure. Yeah, we mentioned all of that stuff before as we're getting started. We got this to run. Now let's go ahead and analyze the results. Let's see if there's anything. All right, that's not good. So here, if we go back into our Kali machine, and hopefully by now your Nessus has completed scanning. If not, I included Nessus reports as well as the Nessus database that is in our Google Share Drive if you want to reach out and download that. All right, so let's go through. Let's see, Nessus is here. Here I am, Nessus, just in case you don't have it still running, you know, it's at HTTP, whack, Kali, you know, your local host on port 8834. And then that should lead us to the login page here. So we log in, sign in. And when we sign in, you know, I gauge my eyes to this right side here to see that, yeah, I have everything is complete. You know, the scans are done. It's not still scanning. If it's still scanning, I give it time to complete its scan, then we can analyze further. So let's take a look at DVWA real quick. So what I did, I clicked on DVWA here. Now up front, I can take a look at just like a dashboard of the vulnerabilities that it did discover. On the bottom right-hand side, I see out of all of the scans, you know, 33% was information. 6% of the scans were critical. There are some critical vulnerabilities running on this DVWA image, and also high. So critical, high, I look at those first to see, okay, where am I really going to pivot and throw an exploit. Medium could also have information that's useful to us. Low, you know, just GWiz, probably just a slight lower version or whatever is the low, and information. And then here, vulnerabilities, if I wanted to click on them, I can pivot into the vulnerability side. I'm going to click right here on vulnerabilities at the top. Let's click on the vulnerabilities tab. Vulnerabilities tab, I click on the vulnerabilities right up here. Now, it provides information to us, but these things are still grouped. So one of the things we can do, coming over here, if we change this settings here, yes, I'm going to do settings, disable groups. So here, settings, disable groups. And now the other groups are disabled, and hopefully it is ordered or it's sorted by severity, in which I have my most criticals up top, high, medium, and then you see right here there are more. At the bottom right hand side it says it is showing 1 to 50 of 103 alerts that Nessus has provided to us. What I'm going to do, this 50, let's expand that to all just 200. Show me everything. And we'll go through them and see like what is useful and what are we going to wave our hands across. So back here at the top, I'm going to look to the right just again. The dashboard of vulnerabilities, we've spoken about the end time. This scan only took 3 minutes. Some scans can take a long time, especially scanning a real server that is in another country far from you. So here, Apache, each of these vulnerabilities, I'm like, oh, critical vulnerabilities, critical? We're gonna have some exploitation today. That's what I'll be thinking, right? Based on what Nessus might provide to us. So clicking on critical, in our notes, I would already start, each one of these critical that is identified, I will write those down and say, okay, let's see if we can exploit these. Let's see what it looks like. What can we find from the vulnerable machine, right? So I'm looking at this Apache 2.2.x, and is less than Apache 2.2.15, multiple vulnerabilities. So what the saying is, according to its banner, the version Apache 2.2.x runs on the remote host as prior to 2.2.15. And this is therefore potentially affected by multiple vulnerabilities. And then you just read the description to see like what type of vulnerabilities are out there. I see CVEs. Okay, a flaw in the code, can lead to sensitive information being requested and handled in the wrong threaded environment. Now to the right side, so critical description is here. It gives you a solution like, hey, what should I do? So this is really good for like the system admins out there. Scan your own enterprise, your own system is like, well, what should I do? Well, okay, upgrade. Some of these are like upgrade, deny access. It's usually some message of upgrade to the specific version or better. At the bottom side, or at the right side, excuse me, it talks about the risk information. Risk information. So here, risk factor critical. So it has been exploited in some version, at least that has been reported to this Nessus scanning engine. Okay. The CVSS base score of 10, 10 is really high. 10 is good. It's 1 to 10. In Nmap, when Nmap is also scanning, it would give us that same risk index of 10, 9, 8, 4. Usually, if it's below a 7, I'm weary if my exploit is actually going to work against it. 10, most likely, but in tested environments. VMs that we know is configured. In the wild, if you just launch a Metasploit against another system, most likely it's not going to work. You have to adapt your approach. Because hacking is costly. We don't always intend to use these open source tools to carry out the attack, but this is the way the attacker would begin, and then you advance from this standpoint. So I'm also looking at vulnerability information, PPE, its header that Nmap is also able to provide. Exploit, is an exploit available for this? Yes, it is. Exploit ease, how easy is it? An exploit is available. Other times it will say exploitable with, like down here. So down here where it says exploitable with, this one says core impact. Core impact is an older exploitation framework similar to Metasploit, but I want to say core impact was proprietary, like you had to pay for services, and I'm not sure if it's still used now. I never used it, just knew of it at the same time with Metasploit. And then references, additional references based on that vulnerability here. So it's really high vulnerability. And here are some other CVEs that we can find. Now, since we have that, let's go ahead and look at search exploit real quick. So here I am. We know that this is a potential vulnerability. Before, we scanned for Apache 2.2.14, but with this CVE that we see just in a different measure from Nessus, let's search exploit and search for a CVE. So I'm just going to enter in 2007 6750. Okay, and I put in this CVE at the bottom right-hand side. So that one it didn't find. Let's try another. And that's okay. I mean, this is exactly what we'll do in the real world. 2009-3555. That one wasn't found. 2010-0408. Nothing in that. 0425. 0434. Let's see if anything. So at least from those initial, nothing was found for the CVE. It could also be the way the CVE is written and stored in the database. Let's see if there are other numbers we can try and search for. Now I'm just going to try the last 4 and see if that gives a better hit. 0408. Doesn't look useful. Let's try the 0425. Doesn't look useful. What else do we have? 0434. 0434. Yeah, so at least doesn't mean the thing is not present, but search split did not find something. That happens, but for sure, I'm still going to try and exploit this because we did find results for Apache 2.2.14, which is our version that we have. All right, something else to look at. Output. So this is a specific output that Nessus was able to procure from the remote system, and then it provides you that information down here below. Apache again, 2.2.1.4, just as we did before with each of these that you find. So exploit Apache 2.2.14. We do have a few, and this one in particular is one that we might take a look at. Installed version, fixed version. So this exploit that is talking about that's critical, it is no longer present in version 2.2.15, but it is present in 2.2.14. And then it tells you at the bottom which ports did it scan, does this information, is it applicable to? So it's applicable to ports 443 and port 80. And then we look through each of the entries to see like what are we possibly going to try and exploit against the system. Open SSL, critical, PHP, operating system unsupported version detected. Again, Apache here, it's high. Apache that it detected. Let's look at one of these. In the high, it gives you information. Null pointer dereference flaw exists from a third party module. It's an installed version. This is when it was fixed. Quite a few versions later, potentially. And now I come in. I said there's a description. It is high. Ports against port 80 and port 443 TCP. Then on the right side here, this one is saying that there is no exploit available that it knows of. Its base score 9.8. There's possible high vulnerability. And then other CVEs. So again, each of these we'll check in search for it and see, okay, which ones are there? Start writing down, and we get ready to launch a Metasploit against. Let's see what else do we have. So we have other vulnerabilities. And then we click on it, we'll read, we'll spend time here. Apache, OpenSSL. So this poodle, this was a DOS type of attack, I want to say. I think this was a DOS. So according to its banner, OpenSSL, is prior to 098ZC. Is reference, it is affected by the following vulnerabilities. The way it handles SSL padding bytes and decrypting block ciphers. Oh, okay, so this one, man in the middle. So a man in the middle attack is possible. Now on the right side though, this base score of 4.3, to me, if I'm thinking of all exploits I want to run, this 4.3 already tells me, nope, I'm probably not going to try this one on my own because it just might take a long time. I want to go for the ones that work first, and then go backwards from there. I go from what's easiest now, and then I start working my way up to what's hard and takes more time. And then some CVEs. Ports, and then version information. Let's see if there's anything else that stands out to us. OpenSSL, PHP is there. Okay, now I'm in the low severity columns by Nessus. Info is able to determine some services. Services is good. You know, it's nice to know, like, hey, this port and this service is running potentially with banners also that Nessus will provide to us. So we see that there's an FTP running, port 21, SSH servers running, 22, web server, encryption, SSL over HTTP, or TLS, SSL, yeah. Okay, 443, and then 3306 for my SQL. Yeah, my SQL is running on this port. All right, going down, service detection, Nessus scanner, web server, robot text information disclosure. We went through the robots before. WebD AV. So it detected this, no output, just informational purposes, nothing useful there. We'll take a look at this one. Common platform. So it can determine, it might be able to determine some platform hardware, software configurations. So this is good, in which the remote operating system, so this is even better. It's more precise than our Nmap scan. Because our Nmap scan for the operating system, it told us it was like Linux, Unix, or we knew it's Unix, but not a specific version. So this one is telling us it's Ubuntu version 10.04. So that's good. This also lets us know that what exploits might exist against other processes on the operating system. All right, so that's nice. That's good to know. Ethernet card manufacturer detection, MAC address. So we got a MAC address, and using the OUI, organizational unique identifier, it's like, okay, it has a MAC address of maybe VirtualBox or VMware or something like that. Yeah, so MAC address is able to determine that. MySQL server detection. Okay, and I think that's about it. That's about it. I'm curious on the Ethernet table. Yep, so the first 6 bytes is like, okay, PCS, yeah. Just informational. And then there are steps. Sometimes it might have remediation here. Like, hey, update your PHP, update your SSL, update your Apache. And basically, it gives these initial indications, like, hey, here's some information to update. And then history, just some things that happened recently. Okay, so that was review of DVWA. Are there any questions with that? Any questions, issues, thoughts? All right, I'm not seeing any questions down here below. So for right now, look through Metasploitable 3. And let's compare some of the notes that you find. Some of the things that you say are interesting. Just as we did before, we come in here. I'm going to go straight to the vulnerability. Let's see that there are 96 entries. We have already ungrouped the entries so you can see them in severity. So review, spend some time, I'm going to enable 200, so everything is here at once. Just look at this and put together like an initial vulnerability or an attack vector list is basic. Port, service name, maybe vulnerability like CVE. Right? Spend about, let's do 10 minutes of this, then I'll come back. We'll talk for a little bit. Then we'll go on break and we'll immediately go into Metasploit. All right, very good. So I hope you just have some time to look at it on your own. The whole purpose is just to see like what is out there, what is interesting to you. I will point out a few things that are interesting to me, so then we can compare and share some notes, and then we can get ready to pivot into Metasploit. By that easy chart, simple things, just notes to write down. I write mine similar to this, and it changes slightly, but let me show you this real quick. On the slide, this is what I mean by we build that initial table of potential attack vectors. And again, very basic, doesn't have to be anything fancy. Just the ports that we're interested in observing, interested in analyzing, performing an attack against. The service, what is the name or keyword that I can use to search for it? Like Manage Engine, Desktop Central, 8, Desktop Central 9, Microsoft IIS, etc. Just what is the name about it? Vulnerability, the CVE. As I mentioned, I really like the CVE. The CVE, the OSVDB, different databases out there, IAVA, IAVA, different keyword indicators. What can we provide for that vulnerability here? And then is there a specific exploit? The exploits that I list here are from Nessus. There are times that Nessus will tell you, like, this is the exact exploit in Metasploit that I can run to exploit this vulnerability that Nessus has just uncovered. So if you do see that, you can put it here. And as you exploit, you analyze the system, you check for what's vulnerable, what's not vulnerable, you come back and enrich the list. You say like, this specific vulnerability worked at this instance on this system. Program version name or the program version, always include the versions there. And then you also enrich with all the other scans that we've done. So Nessus might not find everything. When we went through Wet Web, we went through the OAuth ZAP, we did directory traversal, which other attacks or entry mechanisms might be useful. We can include that here in our entire list. From Nmap, Nmap gave the vulner, remember the vulner scripts on those specific CVEs, which of those are going to be useful to carry out for our attack. And then in the Nmap vulner script, we also use the Nmap vuln, the vuln script. From all of that information together, right, it gives us an idea of what to attack for. You can also filter vulnerabilities on Nessus' side. The filtering is, I put some ideas that I initially will come in and filter for. So RCE is like your remote code execution. I might want to search for that first and say, okay, what's most likely for remote code execution or remote code web? If I want to look at different websites, web services out there to do additional analysis, additional directory searching, directory traversal, search for what does Nessus find out about different websites that we're scanning. Or traversal, perhaps it has discovered that directory traversal is possible. What are our indications up front? So if I go back, what I mean by that, the filtering is right here in the filter. And we do filter RCE, EE. For remote code execution, I might start here. What will allow me to do remote code execution? I'm going to throw an exploit. Hopefully I can get access to the system. I can launch my payload on the victim machine, and then I can have remote code execution. It can execute what I've given. Right. So this is one of those. I included on my list. This is Manage Engine Desktop Central either version 8 or version 9. It gives us a description, it's bad. Okay, so the output right here, you see the output, it tells you that it is version 9 and the specific build. So on my list, my desktop central is version 9 on port 8383. Yep, version 9. So we definitely take the port and the version if we can find it specifically. Then on the right side, I see exploit. Exploit is available, like on exploit DB. The base score, that index for how critical, how likely is it a vulnerability exists against this 10. So a vulnerability exists and has been exploited against this service. And then a CVE. So if I wanted to, I can pivot into that CVE. Oh, CVE is not found. Yay. CVE, that was 2001-5. Where is that? 82001. So it's likely, yeah, I was just there, sorry. We can't find this. So it's likely that the CVE has changed. It could have changed this number. Actually, I could find more on that CVE. It's fine, we're still gonna exploit it. All right, going back, we're still looking under RCE. For filter, remote desktop might be vulnerable to remote code. Blue key, no output. Now it says maybe, it does look possible, right? But there are different versions. So we're not sure what version we're running just off of this just yet, but we'll still give it a try and see. Desktop remote protocol, exploit code does exist. Exploits are available. Metasploit. So specifically in Metasploit, CVE 2019, it says Bluetooth RDP. This even tells you like, hey, when in doubt, use this. So one thing, if I look in exploit DB, search exploit, and let's see if we can enter this one, 0708. Another one that did not work for us. Oh. Blue key, let's try search exploits. Okay. So looking at the blue key, so I use this keyword. Okay, so for blue key to determine are there RDPs that we could try and use. Now in this instance, there's a denial of service Metasploit, a Windows 7. Ours is not Windows 7, and an RDP, but they could be the same program. So if I'm not sure, I would still try it. We just don't know if it's going to work exactly because it's not as precise as we would have expected. Okay, I see DNS resolution 5355. So I'll write that one down. DNS 5355. On the right-hand side, it says Metasploitable buffer underrun, and we have CVE details. Here we are with source exploit. Let me clear. With search exploits, let's try this one, 0657. No. Let's try entering the DNS API. Okay, so I do not find that here in the search exploit, but it still might be present in Metasploit. I just like to start here. This is also another one I could have that. Oh, the RDP remote desktop. Have you written that one down? 3389. I have that written down here. 3389. Along with the CVE at the bottom. Apache might be vulnerable. Nessus was able to exploit the issue, okay, with the following request. And it says file inclusion vulnerability was found. Remote unauthenticated attacker could exploit this vulnerability to read web application files from a vulnerable server and potentially also execute or gain remote code execution. That was port 8009. CVS score 9.8, really high in different CVEs. Elasticsearch, I see, as a high. Elasticsearch ESA. Elasticsearch on port 9200. Always want to know the port that we're going after. And the installed version is reported as 111.1.1. Then on the right side, we're reading that Elasticsearch exploit, no known exploits are available, at least in this Nessus. Let's see if search exploit will have anything. Doesn't look good, but what if we search Elasticsearch exploit, Elasticsearch. Okay, so in these ones, in searchploit Elasticsearch, it does have remote code execution 1.6, arbitrary file download, and versions less than 1.45 or less than 1.52, directory traversal is possible. Or arbitrary Java execution, dynamic script. So we do have some things that we will go after under the victim system. So Elasticsearch again, same port, so the same information for us. Remote desktop cloud, SMB, Eternal Blue. Oh, Eternal Blue is a lovely exploit when that one came out. It was almost like the MS06, what was it, 06068, 07068, RBC decom on the Windows XP machines. Eternal Blue is a good one. Okay, on 445 SMB. Still have an Eternal Blue, 445. Yeah, SMB. Relatively high score. Exploits. So that's nice. Here it tells us the exploit that would work. MS17010. Eternal Blue. Eternal Blue. Okay. And lots of CVEs, like this well-documented vulnerability, this one. Did we talk about Glassfish? Oracle Glassfish might be vulnerable also. 4848. Glassfish server. Managed engine, desktop central, version 9. We wrote that one down already. It says multiple vulnerabilities. Port 8022 and 8388. Managed, managed engine, desktop central 9, 8022 and 8383. Yeah, so these are build 9, so we will include these. Okay, TLS signed certificate information. Elastic, we wrote down stuff on Elastic. Vulnerability with Microsoft IS Cloud, information disclosure. So path traversal. Again, we are interested in that path traversal. The 4848. And that's also due to Glassfish. Glassfish. Let's see what else. Cipher, terminal encryption, medium low, Diffie-Hellman, bad key exchange, Nessus, service detection. So we saw this before, different services it's able to identify. There's an FTP running on 21. SSH server is running on 22. Web servers are running on 9200 and 8022. We have those down. 9200 is Elastic. 8022 is the managed the desktop engine central. 9999 was that Abyss web server. 80, I can't recall what's running on 80. There's also something running on 8000. So all of these we will also try and do a directory traversal against and see if we can determine information from it. No, I think Abyss is running on 8000. I think so. Just some of the ports that's given us 8000. That was this HTTPS. HTTP 169. So I'm just going over to the. I'm looking at the ports that says it's running a web, and I'm curious. I'm going to see what is actually out there. Maybe I might be able to deduce additional information for the attack. 8000. Web service that's running web stuff. Did we look at 80? I don't think we have. What's on 80? So this thing that says, haha, there's a server running and returning this image. 8022. Sorry, dots 81. Managed desktop engine is running here on 8022. We've seen this one before. And I'm just looking at the ports, just trying to select what website is out there. There's a GIOP service running on port 3700. TLS v1 is running. So these, if I wanted to go back at HTTPS and see if these provide any additional details to us. Or 848. Do you want to accept the certificates? Yes. Accept the risk. So this is an Oracle sign-in. Something like this would use against a brute force to see if maybe we can try and gain access to it. There's the one that takes admin. Nope, not that one. For 8. The TLS 8443 is another one. 8443. Yep, 8443. Guess we didn't see anything in that. 8181. Particular server is running. File overwrite is possible. Just looking at this from Glassfish. 8383. And another thing that could be possible, like as we saw, Glassfish is running on 8181. If we have an exploit, we could also try and hit it on 8181. So we found other areas, 8181 and 8383. So I'm going to add that to my list of IP addresses for A3. Okay, we had that before for Desktop Central. Okay. All right. So that was our service detection. I'm just going to see if there's anything else that's useful. Glassfish again. Microsoft Manage Engine, Desktop Central. Apache. Elasticsearch is down there. And let's see what else. OS identification. Using a combination of remote probes, Nessus was able to determine the operating system. Okay, the one that we are going after is Microsoft 2008 R2, Service Pack 1. (2008) R2 SP1. Okay, and at least just an initial review, those are some of the aspects, items that I would take note of, and then we will begin to see what we can attack, what information is going to come back to us. So intense, all of those scans take a while, but illusion versus the reality of hacking, you spend time here, so then we can pivot into doing the exploitation and hopefully we can be more successful, or we know another route to try and utilize to gain access to the system, or to compromise something, or to abuse a protocol to make the system perform in the way that we want, that it was not originally intended to perform. Okay, any questions with that so far? All right, I'm not seeing any questions. We kind of went for a little bit. Let us, let me share a slide. Yeah, so that's what we're mentioning. Now we're planning our entry vector. We invest a lot of time here to improve our success later. These are the ports that were open at one time of the scan and some of the service information that NIST and MAP provided to us. All right, now let's get started into Metasploit. Let's go ahead and take a 5-minute break. Is that okay? Let's say 7 minutes so we can start at 25. So 9:25 for me. Just a quick minute break, take a walk, and we'll get started with Metasploit. All right, welcome back. Let's go ahead and jump. Let's just jump headfirst into Metasploits, understanding this, launching an exploit or two, seeing what it looks like, and then learning from there. Okay, just to make sure, sharing screen. Can you see the screen? All right. Thank you. Thanks for the comments. Great. Okay, so hey, let's grab us some shells. So the Metasploit framework, just to understand some things about Metasploit. Metasploit, robust penetration testing framework used by many attackers and defenders, okay, to exploit potential vulnerabilities of a remote host or distant end, whatever it is. When an exploit or a system, when we exploit a system directly via a tool like this, yeah, and this is what I was saying before. So whenever we exploit a computer, I don't exploit the computer, we exploit a vulnerable process. And this can help us find that vulnerable process that could be a server on the back end, launch and execute our code, and then give us access to the computer itself. And then there are specific modules that are built into Metasploit. Those modules include an auxiliary, host modules, no ops, encoder, evasion, exploit, payload, and then interpreter. The auxiliary modules are usually things that are not specific exploits, but it carries out specific functions for us. Some things like the auxiliary modules are scanning. If we want to do additional scanning, additional information gathering from the remote system, we can go into the gathering options for auxiliary, fuzzing, sniffing, and denial of service. The post modules are used for post exploitation. So this is now that I'm on the machine, what else can I do from this point? Post showing us some of the auxiliary modules or so. What else can we execute? No-ops. So no-ops are used to add padding. So whenever we execute a buffer overflow or we have Metasploit generate shell code that we send over to a machine to be executed by the processor. Different processors, different operating systems may interpret this information differently. So we pad to get rid of incorrect bytes that could make our shell code fail, and also to have our code to be within a certain number of bytes that we want to execute, and then we can try it again to hopefully increase the likelihood that our shell code will be successful. Encoder. So the encoder helps us encode, it helps us obfuscate the payload that we're interacting with or the module. So that obfuscation could be an encryption or an encoding. Encryption, encoding, or other type of obfuscation to hopefully evade detection. Evasion is a newer module that has been introduced into Metasploit. 2018. It's still relatively newer compared to the other modules that we have been using ever since the beginning. And the evasion provides techniques to help evade detection and also circumvent intrusive detection prevention system security products. So here's a summary of the models that we just went over. It's very, very basic, but you have the slides. You have the slides, so you spend some time to review and then execute these on your own to gain that expertise. All right, so let's go ahead and let's do this together. Let's learn to use Metasploit as we exploit one of the systems that are out there. This is exciting. I'm going to close this browser. Here we are. Okay, I'm just going to clear the screen, make sure things are clean. We do a little bit of housekeeping here. Get rid of extra tab. This guy's still running. I'm going to stop. Clear. All right, so now we're at a clean state to carry on these attacks, or to start with Metasploit. So the first thing, let's go ahead and run it. Let's get Metasploit to actually run. To do that, we'll type in MSF console. The MSF console is going to start, take a little time, and then I will get usually in fan art or text art, some sort of art. Your art will be different. It uses different sets of text images to show us. Some people will have the cow, others will have the ninja. I have the rabbit for this instantiation. Then something to note is what Metasploit tells you. The exploits we're talking about, it has 2,071 exploits currently loaded. This is the version of the exploit database that it has loaded inside Metasploit. So the next time when we update the system or we update the database, if there's a newer version out there, we can compare the newer version with exploit database to what we have to see, do I need to update again? Did something go wrong with the update? Or do I have everything that's posted free on exploit DB? There are 1,123 auxiliary modules that we could choose from, 352 post-exploitation modules to use, 592 payloads, 45 encoders, and 10 no-op options. And then lastly, the newest one, evasion, there are 7 evasion options. Now, there is vernacular to go over just briefly. When we talk about an exploit and a payload, an exploit is what I use to gain, to like take over a vulnerable system, a vulnerable process. Okay, that's my exploit. Now, when I've taken over that process, the actions that I carry out, that's my payload. So the exploit is used as the tunnel mechanism to gain that initial foothold to the system, and then the payload comes through to carry out the effects, the attacks, like the missile that I'm firing over there. We will use the interpreter as our payload. So there are different types of payloads that you can send. I mean, there are over 592 payloads loaded. Some of those payloads would be like a Windows command prompt. You can send a specific Windows command prompt over to the system. You can send like specific commands to execute. You can send shellcode as payloads. You can send images perhaps as payloads, whatever you like. We use Meterpreter because it is a highly robust payload that allows us to do command and control, beaconing, and many additional features, and handles that for us. So that's why we use Meterpreter in this walk here. So if we want to look at the exploits, if we type use exploit, so I just typed use exploit, and then in the exploit from the beginning, lots of them. I don't know if my buffer is gonna have. Okay, so we ran out of buffer space, but before it said like 2,000 plus exploits. So these are each of the exploits that we have to gain an initial foothold onto a system. So these exploits take advantage of a vulnerable process. So let's see which exploits that we want to use from our scans. Let's go ahead and start with our Desktop Central. Remember the Desktop Central Manage Engine, it was the first one that I wrote down from our Nessus scan at the top. So let's see if we can exploit that, since Nessus said it has a critical vulnerability. Let's try and exploit that to gain access to the system. Again, what does the system look like that we are taking, we're compromising? This is what we're going to go after. Assume you don't know the password. You know the password because I gave it to you for one of the users, Vagrant. But any other instance, you just have a system here. You don't know the password. Let's see if we can gain access to this computer. All right. So we mentioned we're going to exploit the Desktop Central, the Manage Engine Desktop Central. That one is on port 8022 and 8383. So one thing I would do to search for the specific exploit that we want to carry out is search. So search, similar to search bullet, remember, but here we can say search space, and then whatever it is we want to search for. I'm going to type in Desktop Central. Desktop Central version 9. So Desktop Central 9 is what we searched for because that's what Nessus identified as one of the builds and had a critical vulnerability. So we will start with the critical vulnerabilities and then work our way down. Now, in particular, let us use this exploit. So this exploit is at index number 5. So to specify to Metasploit to use this specific exploit, we can either type it in with the command use and then exploit/Windows HTTP manage engine connection ID right, just as it's written there, or we can use the ID. So the ID is 5. As computer people, we want to save our keystrokes. Like you only have a certain number of keys that you can use on these fingers. So 5 saves our lifespan. So let's use 5. Let's just say use 5. So now, can you see my screen okay? Because I know scroll at the bottom. Are y'all okay here? Okay. Oh, okay. Yeah. Oh, yeah. Interesting. Yeah, you might have a different ID based on the search, perhaps the way the keyboard, came in. If I were to have done, let me see back. If I were to have done search, desktop, I would have a different number of IDs that come up, or search desktop central. And so at this case, now the ID is number 6. It just depends. It all depends on how that keyword is entered to provide that searching for us. And every time you update, your index numbers, are likely going to change, or many of them at least. Okay, so I said use 6 now. So you all used 5 if you had the exact same one as before. I'm using 6 to have the manage engine connection ID right. So now we've selected the exploit. Let's read about it to see if this is truly what we want to execute. So if I say show info, thank you. Yeah, type in show info, thanks Benji. In the show info, I can see, okay, so this is the name, manage desktop central 9, file upload servlet connection ID vulnerability. So you can read more the platform that it's going to exploit, Windows. Privilege is not privilege. So we'll have to look for others if we want to do like privilege escalation, or maybe migrate to another process if possible. Targets, I'll get to this in a few steps from now. But the target is which specific platform I'm going after. Every operating system is different. Every service pack is different. But here, if there's only one, and usually that's 0, so it works on the main platform that this can be installed on. Oh, good. So if you see this where it says check supported, I would show you what I mean by that. When we enter in the check command, not every exploit has a check command feature built in, but this one does. And so when we put in all of our parameters, we can enter in the command check, and then it will reach out. It will do a quick handshake with the machine. It will determine based on the way it responds, is it vulnerable to this exploit? If it was not vulnerable, it will say like not vulnerable or check is not supported. But it's nice when check is supported. And then here, these are the basic options that are required for this exploit. In the basic options, we definitely pay attention to required. So when it says not required, we don't have to enter in any specific commands for it. When it says yes, we have to enter in a directive to fill in parameters here. So in this case, our host, that's the target host, the remote system. Our host is remote host that I want to go after. L host is the local host. That's our IP address for the connection to come back to us. Our port, the remote port that we're going after. Target URI, we can specify a path for this engine. It will start at the root, if not. And then vhost. So remember 2 days ago, it was either yesterday or the day before, when we did scans, we saw scans on a vhost. If you enter an IP address, that single IP address may host hundreds or thousands of domains. If Metasploit is using a specific IP address to go out to a domain name server, you now have to give it a virtual host to say, okay, now that I'm here, this is the specific virtual host that I want to attack/exploit. And then you have a description. So this module exploits vulnerability found in the managed engine, etc. Good enough, there's an exploit that's available. Let's see if it's going to work for us. And other times, if you have CVE information, so that CVE is here, like 2015-8249. So most likely, if we search for that in SearchSploit, it should have had an indication to this. Should usually, doesn't always, but it's worth a shot. Okay, so here we are. We've looked at the information about that exploit. We're like, yep, that about sounds right for what we want to execute against the remote machine. Now let's do show payloads. So exploit gets us onto the victim machine. Payload is what to do once we are there. We will select Meterpreter. At least to start out with, Meterpreter is so many features, it's the one to start out with. And then as you get further advanced, you will start to use different payloads. And then eventually, you may build your own payload because that is much less detectable than Meterpreter. Meterpreter, every AV out there should detect your basic Meterpreter that we're about to throw into the victim machine. So let's look at the different payloads that are available. If you enter in the command show payloads, and there are lots of them. To show payloads, so these are the different payloads that we can send to the system. So Windows DLL, inject payload, Meterpreter definitely. Maybe it's a patch update DLL, a specific shell like a command prompt that I would want to have, just your basic command prompts. VNC inject, if there's a VNC client, or when we break it to the machine, let's say we want to send it a VNC client such that I can now have a remote desktop-like capabilities on that remote machine, I can throw a VNC client over to the machine. And that's about it. So 187 payloads under this exploit. One more thing to talk about with these payloads. You see the concept of reverse and bind. So reverse and bind. Bind, in essence, from my attacker machine, when I send my Meterpreter over, exploit goes over, exploit sends shell code, and Meterpreter, that's our malware that runs in memory resident on the victim machine. Now I need to connect to Meterpreter in order to communicate and carry on my command and control features. So bind means when I send Meterpreter over as my payload, it stays there, and now it's listening for new connections. So binding, victim machine is over here, Meterpreter is there. I now bind to that Meterpreter, so now I have command and control. Reverse means, as I throw my exploits, gain access to the machine, initial foothold, Meterpreter is established as that payload. Reverse, now that Meterpreter is going to establish a connection back to me, back to the attacker machine, so now I can interact and have command and control with the system. There are different reasons to use bind and reverse. For the most part, as I'm across the world to all these other machines that we're scanning, I'm definitely going to use a reverse, because if I try and bind over to it again, firewalls may likely, detect me and prevent my bind connection. But a reverse, usually the firewalls assume that, okay, a protected system inside my network wants to establish an outbound connection, I'm going to let it go because of the initial direction. So reverse is going to come back to us. We will use Meterpreter reverse connection to our systems. Okay. So to do that, we'll use the command set payload. So set payload, and then we could actually use the number if we see it, reverse TCP Meterpreter. So Windows Meterpreter reverse TCP. There you are, 38. So Windows Meterpreter, no, that's bind. Reverse, 50. Okay, so I'm going to use Windows Meterpreter reverse TCP and 50, and then it does give us more information about the actual stagers and the exploits the payload that we're going to execute. So I'm going to use 50. Okay. So here, set payload, so it's set one automatically, which is the one that we're going to use. If you did want to change it, I'm still going to change it and say set payload. So I like typing. And in this case, I want to use my keys. Set payload 50, just to be sure. So again, it's saying that it has set the payload. Older versions, it doesn't do an automatic payload selection as this newer version of Metasploit does. You actually have to say set payload 50, or even type it out, Windows Meterpreter reverse TCP. So now that we've set our payload, we need to look at the targets that are available for this particular payload. So if I type in show targets, so show targets, let's see which platforms is this going to be, does this work for? Other times you'll see Windows XP Service Pack 1, 2, 3, or maybe Windows XP Service Pack 1 and 2. And now if you're executing a machine that's Windows Service Pack 3, this payload will not work with that. The same thing if I'm exploiting a Windows 10 machine. Yeah, so sorry, in case you have additional things that are listed here as platform, that's just what I'm trying to get at. You know, follow the platform. If there's only one listed as 0, hopefully it's going to work for that platform. Otherwise, you have to be specific and choose that specific platform to the operating system that you're going after. Sorry, trying to explain things and just sometimes it's good just to be simple. Okay, so show target and then set target 0. So my target is still set, so nothing necessary to do at that point. Now we've entered in some of the information. Let's specify the remote host and then the local host. So set our host, remote host that I want to attack. My remote host is 169.254.8.81. That's the remote host we're going after. Ourselves, and just to be sure, on our IP address, if you type in ifconfig, Metasploit is nice to enter in your ifconfig details, and I'm going to use this one. So I'll use set lhost, and that's our local host to come back to us when we do the reverse connection. So set lhost 169.254.8.82. Now let's type in show options again, because we want to verify we filled in everything that is required for this exploit. So we type show options once more. We should now see that our host has been filled in appropriately, and we verify the IP address 169.254.8.81. That is our Metasploitable 3 machine. The R port that we're going after, so this one is 8020. 8020 was one of the ports that we saw. Another port is 8022, and another one is 8383. Since this one is starting on 8020, let's go ahead and execute on that. As we saw from our scans, 8020, and it should be open. And if it fails, then we'll come in and change it. So if you did want to change the port, the remote port that you're going after, that command would be set our port, and then whatever port that we want to give it. So if I want to set it to 8022 just for examination purpose, 8022, I can say set port 8022. You see, it acknowledges the command. And if I type show options again, you see that the port has been changed to 8022. But I'm going to change it back to 8020. We'll start with that, and then we'll change ports if this doesn't work for us. Okay, so set port 8020. Now we're seeing if there's anything else that we have to fill in. This is specified, yes. Our port is specified, yes. Our host is specified, yes. We gave it lhost down here that is required, yes. L port, it will try and establish our listener on port 4444. Common meterpreter port. This exit function is fine. There are parameters that I put in our slide that you could change that, but this is okay for this purpose. Now, if everything is ready, let's execute the check command. And you saw previously it said check is supported. So what happens? Metasploit reaches out to the system to see does it appear to be vulnerable. It says yes, this target appears to be vulnerable. Okay. Now we hold our breath and we get ready to execute the exploit. To do that, there are two commands that you can use. One, you can say run, and that's the newer command, or the other one is exploit. I'm going to be the old school and say exploit because I really want to exploit this machine. So exploit. Now we hit exploit and we're trying to take over the system. If we can take over the vulnerable process, we will then send Meterpreter over there. And if that is successful, Meterpreter will connect back to us and we have a Meterpreter shell. So at this point, you have to do the obligatory happy dance. Happy dance is mandatory. We have to dance that this exploit works so far, because in the real world, it doesn't always work. Most of the time, it doesn't work, and you have to adapt your approach, or you actually have to begin writing your exploit from scratch. But once we gain access to the system, exploit is looking right, you must happy dance. Happy dance, it's mandatory, obligatory, there is no exception. The happy dance must be made. We're happy. All right, now we've gained access to that system. Let's ask ourselves, like, what do you do? How do I know I gain access to the system? All I'm seeing is a black, command prompt. Well, there are some commands that we can run to determine, am I on that system? From interpreter, if I type, let's see, sysinfo. Sysinfo is a command on interpreter. Sysinfo, so before I did not have access to this machine. Now it gives us the computer name Vagrant, the operating system, Windows 2008. Okay, the architecture, 64-bit, English, workgroup, logged in users, 2 logged in users. And then the interpreter we're using is the 32-bit version of interpreter. I can execute additional commands, like if we want to do enumeration to figure out some things on this victim machine, I can type PS for the process list. So it's good. We will utilize this process list in further detail. But the process list tells us at the top here. This is the process ID of the program running, and then the parent ID, the process ID, parent process ID, the name of that running process, architecture if it is discovered, and then the user it's running under, or path if it knows additional information. Okay. I can check some routing information if I type in ARC. So this is useful in a real machine to see, like, who can that machine reach out and touch and talk to, or who has it spoken to before, because this could be routes that we will want to pivot to other machines, right? Or we'll add a route and then we'll begin scanning again from this hot point to try and exploit other systems behind the firewall. Because you gain an initial foothold, there are other computers that could be there that you might also want to attack as well. If we enter in the route command, route, we can see different IP addresses that the interface has access to in its closest hop. There is IP, did I do IP config already? IP config. This can also tell us additional interfaces, etc. Okay, here we are. Sometimes you see that there are private interfaces that now will establish a route and then connect over to. Netstat, I'm sorry, I just typed it in quickly. If I type in netstat, lots of things running on this machine, but this is its network configuration, different programs, and it's also nice. So this is an added feature that not only do you have the netstat, the IP address, and the listening port that it's on, listen state, it gives you a state, but it also gives you the parent, it gives you the process ID and the program name. So it's nice that you can associate it without having to do 2 commands to pair or to match your netstat and then your process list, and then to see who's listening on what. Remember, we saw these ports in our nmap scan, and that did not know the process that it was associated with. Here we see that it belongs to Elasticsearch. Process ID is 1384. Okay. And now we need a command ourselves. Another enumeration command necessary is get PID. Simple. So this get PID command This lets us know of what is our process that we are operating on the remote machine, get PID. What process is it? Because this gives us information of, like, where am I? Who am I under? Right? Get PID 332. So if I type in the PS command again, and my PID is 332, I see here that this is the process that we have exploited, right? And this is the path. So we are truly at Manage Engine Desktop Central Server, then, and that's the Java program, or that's the program that is running that we exploited in that we're in right now. Its parent process, 332, is 1668. So if I look at 1668, it's run by java.exe. And in that Java process was established from 1140. So 1140 is a program called wrapper, a wrapper program. And usually that is the jar file was wrapped to become an executable. So the executable runs. So that's what we're likely seeing at this point, wrapper. And wrapper was now called from 472. So process 472 is services. So services is usually an elevated privileged process than where we currently are. You usually end up as a user level permissions, and then we will try and migrate our way to exploit our privileges and to carry out additional attacks and effects on the machine. If we type in help, so Meterpreter will provide lots of commands that is built into this program right now. We just type in help and we can see, okay, what else might we want to run? There's an info command. So let's type in info. Prints information about a post-exploitation module. Let's see what else do we have here. There are other commands that are necessary. So migrate is an important command to use, because whenever we exploit a machine, think of it as I am barraging a process. The process was not meant to execute my commands. That process is likely to die. It's likely to die at some point, freeze, crash itself, crash the machine, give a blue screen of death. It depends, because you're doing something it was not meant to. But usually whenever I get into a system from Metasploit, I will always think of, okay, where am I going to migrate to next? I want to migrate to a safer memory space such that I might be able to persist longer on the computer system. So recall when we were doing the process walks, we looked at what PID, called what PID, called what PID. I will start to move into a separate process space. All right, we can try that now. If I do get PID again on that process 332, I do not want to stay in 332 because this one is likely going to die at some point. So let's see if we can migrate into its parent. So its parent process is 1668. Again, this does not always work. Other times when you do this, it might even crash. It just depends. So to try and migrate, I'll enter the command migrate, M-I-G-R-A-T-E, 1668. And we'll see if we can migrate to another process. It doesn't always work. Sometimes it does, sometimes it doesn't. Okay, now thankfully it said the migration was successful. Migration completed successful. So now let's do a get PID again. And we can see we're operating now under process 1668. Just a few things, and then we'll wrap up, because there's a lot I put in the slides. So there are so many additional commands that you can try and run. Always, when we do gain access to the system, we would also try and upload. So we're using Meterpreter. We would also want to upload a separate mechanism to try and guarantee persistence in that machine. There are other tools, botnets, ransomware, that the attacker could try and upload now, and then we can also try that and see how that system might perform / respond to those attacks. Okay, print working directory, remove directories. We can search for files. So many things that you can do. One, I would like you to see get priv. So I doubt it's going to work. It's not going to work at this case. We won't continue. But get privs and get system. These are commands that an interpreter will try and use to elevate to higher privilege. So you can get like admin or root level privilege on the machine, which now makes it easier to dump passwords, dump password hashes, embed yourself, write the registry, do additional persistence as necessary. So the command, can you run Mimikatz from Meterpreter? Yes, you can. And there's an additional command that you use to say, all right, I want to load Mimikatz. I can't see that specifically here. If you give me a couple of minutes, I can try and search for it. Or someone can Google it. I can't remember it offhand, but there's a separate command that you're like, all right, I want to load Mimikatz into Meterpreter, and then you can interact with Mimikatz from Meterpreter. All right, there's something else. So Enum desktop, you can list different desktop items. You can try and send keyboard strokes over to the machine. You can play a sound. You can try and play sounds, upload videos, start keys, screen share, or a screenshot. We can try a screenshot. We can see if we can. Okay, so it wasn't able to do a screenshot. Other times it will let you do a screenshot. You can determine users on the machine, etc. There's so many additional things that you can do simply from Meterpreter. However, we're out of time to continue moving forward. One last command. Let me do one last command real quick. If you enter the command background, okay, so if you enter the command background, this brings us out of that Meterpreter session, but Meterpreter stays live. It stays active without me closing the session, and I don't have it again. Now that Meterpreter usually will try and beacon back to us, but just in case we background the session, so now I'm out, I can search for additional exploits to run on the system. Okay, so here we went through the steps just to exploit manage engine, right? The desktop central engine version 9. There are many vulnerable processes that are running on this system. The next thing for you to execute would be to run through the exact same steps that we did. And if I show you on our slide, so here in the command summary, I put on the slide that you can go through the exact same things that we ran earlier to make this work. MS console, that's how you start it. We search for desktop central, show payload, set R port, L port as needed, show target, check, exploit, and then happy dance. You must happy dance once you gain access. Every access you gain to the system, there's a happy dance for each of those. Yes. All right. So you can simply change this. When I said it's a variation on a thing. Right here where you search for desktop central, this is where I can search for other exploits out there. So before we did desktop central, another one we could search for, Elastic. Okay. So now I can interact with Metasploit again. I can do the search for Elastic search and see which one of these Elastic searches that I would like to execute. And then I can start from use and the index number, load the exploits, payload, those type of options as necessary, show option, check, exploit, and now I can try and gain additional footholds onto the same machine. So in essence, this is how you rack up multiple shells to the test machine. In real life, you only work with one, upload your true implant, and then clear off of that system, and only let your implant run because Meterpreter is highly, it's detectable. Okay, but here, as we're learning, learn with more exploits, learn with different functions. I put a couple of instructions in the slide so you can see 2 or 3 more ways that we can scan the system. There are also auxiliary payloads that you can run, such that now I'm on the system. If I search for auxiliary, it can show like different types of enumeration, scans, user analysis on the system, directory traversal. You can enable these and then start to search and scan the system further. When you're done with all of that, and if you want to re-interact with your Meterpreter session again, if you type in the command sessions-L, right? Sessions, that's L. This is to list our sessions. List the previous session that you have. And then if we want to go back into one of our sessions, so as an exercise to the expert, gather, create more sessions here, have 4 or 5 of them. And now you can start to interact with different ones. Some of these sessions may be more privileged than the one that you currently have. If you can gain a more privileged session, or you can migrate to a more privileged process, then you can enhance and do like the hash dump, add new users to the system, exploit, carry on more privileged attacks as necessary. So if I want to re-interact with that interpreter session, if I enter in sessions-I, and then the ID number 1, now I'm back in interpreter. And then from here, I can type get PID, sys, that sysinfo, PS for our processes, etc. So I can continue working on the system. I can also type in commands like execute. If I want that system to execute a command at a specific path, I can say execute. Load Mimikatz, thank you for finding it. So if we want to try and load Mimikatz on to give us additional commands, if I type in load Mimikatz, okay, so now additional payloads are have been loaded onto Meterpreter. So load Mimikatz and then type help one more time. Help. And then there should be a Mimikatz session. Yeah, here it is. So before, we didn't have the commands below for memory dump, memory analysis. And we'll try that real quick. I'm doing this one on the fly. But thanks for finding the load command, load Mimikatz again. Now with load Mimikatz, you can try to execute one of these. There are like 3 different ways to dump the passwords. Sometimes one of them is going to work fine. Others, you have to take apart different pieces from the registry, put them together, and then try and break the passwords. So here with load Mimikatz, let's try the command creds all, not running at system, execution may fail, so it's not likely to work. To do the get system, you can just type get system to try and elevate your privileges. It's not going to work because we're at, you usually get a privilege denied, right? Operation failed, token duplication in memory, get creds, enabled process, let's try it again, creds all, get system. Okay, so different commands that we could try. One, so this one might work for us, LSA dump. Okay, so we're not at system. So in essence, we have to re-exploit to find another privileged process or migrate into a privileged process. You have Mimikatz loaded, and then you try one of the credential dump commands, or these 2 commands, and then Googling will show like how to put these together, and then you can try and crack them offline with hash crack, off crack that I did configure on your machines for you. There's so many things that we can do, but the additional specific commands, we actually do that in the next session. That's like our exploitation 201. This was the initial scanning to bring us to the exploitation. But you actually have all the skills that you require at this point, because you can Google or do like the matrix. Hey, I want to learn a skill. Okay, the matrix, you download it into the individual, and now they know Kung Fu. So the closest thing that we have to the matrix is YouTube. So if you want to learn like how to do additional features here, YouTube, Meterpreter. Thousands of videos will be out there to show you additional features that you can do in Meterpreter. Extra videos are going to be out there to show you how to do additional scanning, Metasploit, different features once we're in, different actions to carry out onto the system. So many videos are there. YouTube, Google, and that will help you. I also have my resource books that many of the aspects that we went through in this lab were taken from these books. These books are really, really good resources to learn from. I gave you a reference to many of those. And on Amazon, if you search for like just one of them, like this one, that's the Kali Linux, Mastering Kali Linux for Advanced Penetration Testing. I would recommend, if you're interested to read, to learn more, you can start with this book. And based on where you purchase from, there are other recommendations, like if you can purchase from Amazon, there are other recommendations that stem from this book to help you go further. But this is definitely a very, very great start. And then you amass and buy more books and learn more things, and you become better at it. I would also recommend three others, and then I'll be finished. I don't want to hijack too much of your time, but these are really great references that I just want to pass on. So this one did not make it to the slide reference, but the operator handbook. So this yellow book, operator handbook, if you can see, yeah, so the red team, OSINT, blue team, operator handbook. So this one is similar to RTFM. Like this one came out many years ago. This is what we started with. RTFM, really good commands to take over on a system. It gives you Windows commands, Unix commands, RTFM, just basic. I'm going to do something. You can find it in this book. This one is many years old, still good, but many years old. This is like RTFM on steroids, in which you can see many more commands, useful commands, pivoting techniques, etc. in this book. I would recommend this, to add to your repertoire, along with the complete the Kali Advanced Penetration Tester's Guide. Then, as we're working on Windows systems, this is a good book to learn, a good book to, just to get us started. Malware forensics. So there's malware forensics. There's also Windows forensics, a different Windows forensics book. Green, just like this, it will give you a lot of information on how to utilize that system. So when we attack and exploit a system, if I understand forensics, how to navigate, retrieve information from the computer, then I can be even more lethal as I carry out our attacks here. And then the last one, as you can see, this one is well referenced. Let me get this. Yeah, the complete Metasploit guide. So learning more, you can start with a complete Metasploit guide. It walks you through step by step from the very basic scanning to advanced. So this is a really good book to learn from. A lot of the techniques, the basic ones that we went over, is in the Kali Advanced Penetration Testing. So if nothing else, start there, right? And then gain additional books to get further. Okay, so let's stop here. We're out of time. There's much more we could have spoken about, a whole lot more. Like we can spend weeks doing this, but the initial knowledge has been planted. And now you take the time to learn more, invest more, study. As I said, Rome is not built in a day. If I go to the final words, almost there, almost 1 second. 61. Okay, so here are some final words that I just want to say, like, this is only the beginning that we've learned from, only the beginning, but Rome is not built in a day. Your expertise, your experience is built over time with that deliberate analysis, the deliberate engagement to sharpen your skills. You have Metasploitable 3, download the other Metasploitable. There's Metasploitable 2, there's a Metasploitable 3 for Unix/Ubuntu. Try and exploit these. Download an ISO of Windows 7 that Eternal Blue works well on. Exploit that. Look at different processes as it is updated on exploit database and see how can you pivot into your Metasploit framework and try and carry out the attacks. This is how we get better, by practice over time. And you'll see that by doing this, like how you can definitely build that expertise, in a relatively short amount of time. And it's a fun journey along the way. One last thing I will show you, and then we're done. In your exploits scans folder, I gave you a cheat sheet of, there it is. Here. So in case you want to know, like, what other exploits can you run against this Metasploitable 3, there's a GitHub that has these options. So I included a Word document in your folder. if you look at the Word document, it will tell you the vulnerabilities. Like we worked on Glassfish. These are the ports that you should see open: port 484880808181, credentials, admin, exploit. Okay? And then here's the way to access it from your browser, starting and stopping, and then module. So right here. So this is, if you're not sure which module to use when you want to exploit it, take this one, because this is the way to gain access to that system. So go to the commands that we use exploit. This is a specific exploit. You can also use auxiliary scanner if you want to learn more about that, that service that's running in directory traversal most likely. Enter in the commands that we gave you in the command summary sheet, and then exploit, amass more shells onto the system. So there are many credentials and ways that you can access it. And so that's here in this sheet that you have. So now everything I know, you know. And I just want to thank you for your time. It's been fun. I enjoyed this. I hope you enjoyed it. I hope there was at least one or two things that you learned, in the process. You have taught me a lot of things. Thank you for your participation. And I look forward to us doing more advanced sessions, because we go more in depth, hands-on. We also go into some coding and other sessions that we will bring online. We'll also go into some reverse engineering, forensic, whatever you would like. Just reach out to the HackCon team, and we will have these workshops to be created for you to help you in your process growth. So everyone, I wish we could have been together, but hopefully next year we will be able to continue in this process. And take care. Cheers for now. Video and information is going to be posted, and if you have questions, reach out to us. I'm eternally grateful for your time. Thanks again, everyone, and take care.